Good morning, everyone. Am I audible? Okay. So, wishing you all a very happy new year as it is already 8 a.m. in Bangladesh. We are excited to begin the first morning of the year with such an inspiring initiative. So, I'm Anika Tasnim. I'm currently working as a president in ITE BUET Student Chapter. So, today marks the very first of the year, and the ITE BUET Student Chapter is truly honored to launch this major course on such a meaningful day. We are starting the year with the introduction to VISSIM, which reflects our commitment to learning, innovation, and professional growth. So VISSIM is basically a powerful microscopic traffic simulation software that allows us to transform our ideas and imaginations into realistic traffic models. Through VISSIM, we can analyze traffic operations, test different scenarios, evaluate infrastructural designs, and understand complex traffic before implementing solution in the real world. It plays a vital role in modern transportation planning, traffic engineering, and decision making by enabling data-driven and visually initiative analysis. Although VISSIM is not currently offered as a formal course in BUET undergraduate curriculum, we are extremely fortunate and grateful that Shakhawat Hossen Bhai has generously offered us a 4-hour introductory course completely free of cost. So this is truly a valuable opportunity for all of us to gain early exposure to an industry standard tool. It's my great pleasure to introduce today's speaker. MD Shakhawat Hossen is a traffic modeler at PTV Group, where he works extensively with traffic operation, microsimulation, and transportation system analysis. He has hands-on professional experience with PTV VISSIM, VISSIM, and VISTRO, and is actively involved in modeling projects, technical trainings, and customer support. We are honored to learn directly from someone with such strong academic and industry expertise. We are also delighted to share that a significant number of participants have joined us from different countries. Because of this diverse international participation, today's training session will be conducted entirely in English. So with that, I would now like to hand over the baton to our respected instructor, Shakhawat Hossen Bhai. The floor is yours now. And thank you, everyone, and have a great learning session ahead.
Thank you, Anika, for the introduction. And first of all, thank you, everyone, for joining this session. And before proceeding, could you please confirm you can hear me properly and you can see my screen? Okay, sounds good. As Anika has already discussed a little bit about VISSIM, what you can do. So that's a microsimulation tool through which you can do extensive modeling, especially the traffic modeling that you can do into your simulation world. So the term I use traffic, that not necessarily only contains to the vehicles. So under the traffic, pedestrian is also a part of traffic. So you can also do the pedestrian modeling as well with the VISSIM. So and under the VISSIM, so just for the introduction course, probably I can give you a 50 hours long introduction course just only for the introduction. But as our time is constrained and limited, so our today's session is 4 hours, and I'll try to give a initial exposure to VISSIM, what you can do, what you cannot, or what are the and what are the opportunities that you can explore with. Okay, so before proceeding, do any one of you have experience working with VISSIM or at least know the name, how or what it can do, etc. or such? Okay, seems like it's pretty much new to all of you. I've worked with Sumo before. Okay, sounds good. Yeah, kind of similar. Sumo and I believe Sumo is an open source software, and this one is actually a pure commercialized software. Okay. And I also provided the training license, so which is a actually full license with which you can the first 30 participants can actually interact and with the example files that I have shared. And in any of my trainings, I always try to make my training as a video game, not like the movie. Okay, I'll just play and you will just watch. So rather, I'll always try to make it more interactive, just like video games. So just in any moment, if you have any question, feel free to unmute yourself and ask me the question. Okay. Sounds good. So let's go with the today's training session. So our today's training session is total 4 hours long training session with a 30 minutes break at the middle. And the first session, we are going to discuss about the modeling fundamentals of the training. What are the basic things in the VISSIM, what you can do, or what are the network elements through which you can build a network in the VISSIM. So there's a very first part, and there we'll discuss in detail from the scratch. So for example, if you're new world, and if you're given a certain study area, and if you are asked to create a network or to create a VISSIM model, so from where or from which you can start, and what are the things that you need to learn. And the break, then we'll continue with the public transit, because especially in our countries, public transit is one of the most discussed topics, or one of the most important topics, or one of the most overlooked topics that probably we can address by doing proper analysis or proper simulation or whatever. All right. So second part, we'll discuss about the public transit, and through those two sessions, I'll try to give a overall idea about the VISSIM itself. All right. So under the first session, if we start chapter 1, under chapter 1, you'll see about the interface overview. So I have also shared with you the example folders. So if you go to the example folder, and there we have chapter 1, chapter 2, and chapter 3. So under chapter 1, we have 2 lessons, activity lesson 1-1 and activity lesson 1-2. And when we'll be done, then we'll follow chapter 2, chapter 3, and then after the break, we'll discuss the last part or last 2 parts. All right. Okay, so this is the interface overview. When you open a VISSIM software, the interface is pretty much similar to any other GIS software, or maybe any other AutoCAD software itself. So if you are familiar with ArcGIS, it's pretty much similar. The main window is your network editor window, where you will draw everything of your network object, network item, or any kind of rules, regulations, anything. This is your main network window. All right. And on the left side, this is your network object window. So from here, you can select your appropriate network object that you might need to enter into your network. So for example, the first section you see link, then desired speed decisions, reduced speed area, and then vehicle input, nodes, etc. So those are things. And on the top bar, those are pretty much common standard format. Even you might be familiar with all of those bar, even in your Microsoft Word. So you have this title bar, menu bar, toolbar, etc. Okay. So this is the title bar, and this is the menu bar, and this is the toolbar. So if you look carefully on the title bar, we have some few additional information. First thing is it says which VISSIM software you are using. So for example, here you see it says, okay, VISSIM 8 Service Pack 6. And then immediately after the software name, then you will see the file name that you have opened. So for example, this one file name is interface.inpx, and that is located into that folder. Okay, and under the menu bar, there are a couple of menu options, which is pretty much similar to any other software. First, for example, first viewer, file, edit, view, list, etc. And from base data, traffic, signal control, simulations, all are basically related to the VISSIM specific options. All right. And these are the network object window. And at the bottom, we also have another window, which is VISSIM in, which is list window, or okay, and bottom left corner, this is quick view window. So for example, quick view window is a kind of um, real-time window, or you can see your expected attributes here without opening the list table or without opening the attribute table. So that's why this is quick view. Okay, so for example, if you want to see a links attribute or links some kind of specific attribute, if you just select the link, it will automatically show up here. You don't need to open the link list, or you don't need to open the attribute list. Okay, so this is the quick view window. So pretty much that's it, the overall interface of the VISSIM. Okay, now if we go to our first activity lesson 1-1, and from there, if we just open the simulation and run the simulation from there, we can see what it actually looks like into VISSIM. All right. So for example, if you go to the example file and chapter 1, activity lesson 1-1, from there, first thing, in VISSIM, the main file is basically the input file. So anything with .inpx is the main VISSIM file. So under activity lesson 1-1, look for a .inpx file and open it with your VISSIM. So here I'm opening it with my VISSIM, and those who are already ready with the activation key, you should be fine opening this one. And with those who have joined the session with the student version, probably you might not be able to open this one because student version has some limitations. So I'm not exactly sure. So you can try. All right. So here you see this is one of the networks was pre-built on this certain area. And from here, what we can do, we can just simply run the simulation and we can see how it looks like. Is there any question?
What the fuck is this? Not interested. আমি একটা কথা বলি।
All right. So under the signal controller, after opening this one, first thing is here our main purpose is just to run the simulation and to see how it looks like. So to do that one first, we don't need to be worried about the signal controller. So what we can do, let's delete all the signal controllers there. So to delete that one, go to here, signal control, and open signal controllers. And from here on the bottom, just select all the signal controllers and right click and delete. Again, go to signal control, signal controllers, signal control, signal controllers. And from here, now it will open up this window and select this one. And after selecting all of them, just select all of them and delete the signal controller files. All right. So select all of them and delete. So delete all of them and say delete. That's fine. Okay. So when you are done, and now it's time to run the simulation. So you see on the toolbar, we have this icon, green play bar icon. So just click that one and you see the simulation is running. You can pause it somewhere here. You see, vehicle is generating at every starting point, and they're following the simulation. They're following the path. You see. So we can also continue with, if we hit play button, it will continue the simulation. You see. Again, I'm hitting pause. So now it is paused. Now, it would be good if we can look into the simulation, or if we can look into the network into the 3D view. So here you see a box, cubicle box. If you hover over there, it shows 2D/3D. If you select that one, now it is in 3D mode. You see, you can see all the vehicles are there. So you see some rectangular shape instead of vehicles, because for that specific one we don't have the 3D model. That's why they just look like rectangular cubicle box. So for example, if we proceed the simulation, you see vehicle is running there and so forth. All right. So that is the very basic thing. And from here, let me show you a few additional things. So for example, if we go to our view from here, network object. All right. So you remember on the first slide, I discussed about the network object. Where did we remove the signal controller? Because the signal controller was broken here. The signal controller was prepared with some old signal controller module. So with the new VISSIM, those old signal controller module doesn't work. That's why. All right. So here under the network object, if you look carefully, you'll see under the network object we have some subsections, right? So for example, this is the first subsection, this is second subsection, and each subsection is divided with a wider grayed out line, you see? So this is one grayed out line, another grayed out line, another grayed out line. So we have 1, 2, 3, 4, 5, 6, total 6 subsections, right? Okay, so there's a purpose to do those subsections under the network object window. So if you notice carefully, the first subsection is about the network objects input, any kind of network objects input that you probably need to enter into your network for the modeling, that is under your first subsection. So for example, you see, if we are going to prepare a model, we definitely have to start from the link, right? We have to draw the link first. You see, link, then desired speed decisions, reduced speed area, conflict area, priority rule, stop sign, all the way. So those are all input parameters or input features. That's under the first subsection. Second subsection is about related to the traffic demand. So under the traffic demand, you might have volume counts, vehicle counts, right? Or you might have OD. So any kind of traffic demand or any kind of things associated with vehicle input are into this second subsection. All right. Third subsection is related to the output. So when you run the simulation, after the simulation running is done, then the next thing is you might need to extract the output result, right? Or you might need to extract some kind of interpolated result. So any kind of output things or any kind of items associated with outputs, you can find this one under this third subsection. So for example, node, data collection point, vehicle travel time, or queuing, etc. Fourth subsection is related to mostly to the visualization. So for example, background map, or maybe 2D object or 3D object. So, or even 3D traffic signal. So any kind of visualization thing is under this fourth subsection. Fifth subsection is related to the real traffic from your simulation. So for example, when you run a simulation, you remember when you run the simulation, there are lots of traffic or lots of vehicle is showing up in the network. So to get their information, any kind of simulated traffic information that we can extract or that we need to extract, that's under this subsection. Vehicles in network, mostly associated with vehicles, pedestrian in network, that is self-explanatory, associated with pedestrians. So any kind of simulated vehicles or simulated pedestrian, those we can get from this fifth subsection. And last subsection is exclusively for pedestrians. So for this one, into your VISSIM license, you need to have a additional license or additional module. So this one is associated mostly with VisWalk. So VisWalk is doing just the simulation of the pedestrians. So under your VISSIM license, if you have VISWORK, then you will have this option. And under the VISSIM license, if you don't have VISWORK, only the VISSIM, you don't have this option. The training license that we provided, that one also has VSWOC, so you will also be able to see this one as well. Okay, so this one is exclusively for pedestrians. For example, if you're planning to do the some kind of terminal modeling, maybe for example Kuala Lumpur railway station, you want to model that one, how pedestrians arrive there and how pedestrians behave, or maybe airport modeling, how people react from the gate all the way to the boarding bridge. So you can do everything under this pedestrian modeling. All right. So that is the main purpose of having different subsections. All right. So let's go to our slide. Okay. Next option is regarding to the background map. So when we have background map and how we can utilize that background map into our VISSIM model. Okay, so to do that one, go to activity lesson 1-2, and from here you see North American default.inpx. Just open that one. So to open that one, what we can do, just drag and drop it into your VISSIM file. It is asking for whether I would like to save the last file or not. So that's fine. Just click no. All right, so it is opening a new file, and here our task is to import a background map and to rescale that background map. So for that one, first thing is what we need to do. Let's remove them. Okay, so select the background map, that option from your network object window, and into your network editor, just right click and add new background image. Again, first select this one, background image from your network object window. And after selecting that one, come into the network editor window and right click and add new background image. So once you do that one, it is asking for the background file, and go to activity lesson 1-2, and from there select the aerial_ost.tif file. So click open. As I'm working from the cloud, so that's it is taking some time to open the file from the cloud. If you have downloaded the file, you should be good. When you do that one, it will automatically or instantly load that file. It's taking too much time. Let's try again. Oh, it's loading. So once it would be done with 100% loading, then it will show up there. All right, so now it's done. And here we can see the background image is loaded. However, this is not properly scaled. This is one of the intersections, and this intersection is basically this intersection from the image, right? You can see those two are into different scales. So after importing the image, the next thing is we need to rescale the image. So for rescaling, the first thing we need to know some reference point. So for example, for this exercise, we already have a scale that we can apply. So for example, from the corner of this building all the way to the corner of that building, the distance between those 2 points is 4,995 feet. All right, so what we can do, just right click and set scale. And now left click here and hold your mouse. then come all the way to the next point, and release your mouse here. Now, when you do that, now it is asking for the distance. So we know that distance is 4095 feet, right? So put 4095 feet, and now VISSIM automatically rescale the image. So after rescaling, now we know this intersection is that one, and we need to drag it and match the intersection here. All right. You see, after rescaling the image, and you can put the image exactly as the background of the drawn network. So after rescaling the image, we can also verify whether we have properly rescaled the image or not. So now, as per our rescaling, the distance between those 2 points is actually 4095 feet, right? So we can check and verify using there is a measure distance. If you select that one, and if you select this starting point and go all the way to here, you see 4096, 4095.77, almost same, right? So from here, we can easily say, okay, we have almost properly rescaled the image. We can also verify that one by seeing if the network is properly placed on top of the intersection. So seems like it looks so. So we have properly rescaled the image. All right. So now most of the cases, you probably won't need to use any kind of imported background image. Instead, probably you will directly work on top of the satellite image. That could be Google Map, or that could be Bing Map. So we can also do that one as well. Here you see there's a globe icon on the toolbar of the network editor. So if you just click that one, you see it is automatically loaded the network object or satellite image. So from here now, what we can do, if we'd like to turn off the background map, just select any other network object window from here. So for example, just for the training purpose, I select node. And now under the background image, at the very left side, you see there's an icon, toggle visibility in current network editor. So we can either turn it on or it off. So I'm just turning it off. Okay, now here we can see the real satellite image. And this is the intersection. Okay, one thing. So if you need to turn on or turn off something or some of the network objects, just one thing to keep in mind, you cannot do that one by selecting that object. For example, if I'd like to turn off the node or nodes, I cannot do that one right now because nodes is already selected. If I click this one, you see turn on or turn off doesn't work. If I need to turn on or turn off nodes, first thing is I need to unselect node. So to do that one, so let's select some other object. Okay, now nodes is unselected. Now you see that one is working. Same thing for background image. If you need to turn it on or turn it off, so first you need to unselect that one. So I'm unselecting background image. Now I can turn it on and turn it off. Yeah, because the network file was already prepared based on this background map. So that's why it already knows, okay, where it is located. Okay, for the training purpose, so I created the network file on top of the satellite map, and then I turned that off. So that's why initially the satellite map didn't show up, but it was already there. All right. Now, does the software also recognize university road network? software doesn't recognize any of the road networks. The only thing is, first you need to draw the networks on top of the satellite image. So then by default, software doesn't know anything. So only software knows, okay, here is the satellite image, and on top of the satellite image, then we need to draw the network. All right, so here, this is one of the crucial things when we are doing modeling. First thing is we need to define our driving practice or driving conventions. So for example, if you look carefully into the network, most of the cases you will see right-hand side driving, which is also common in North America. And for some of the cases, India, Bangladesh, Australia, or England, you will see left-hand side driving practice, right? So in VSIM, could you please mute yourself? Thank you. So here you can see the blue color is for the right-hand side traffic, and yellow color is left-hand side traffic. Do you see any kind of pattern based on the right-hand side traffic or left-hand side traffic, or do you know why there's some differences on the driving behavior, other right-hand side driving or left-hand side driving? Do you have any idea? Or do you see any kind of pattern? Which countries are common in left-hand traffic, or which countries are common in right-hand traffic? Not necessarily east versus west. Or probably rather you could see northwest versus southeast. It is most likely more prominent on the southeast portion, right? But not exactly that one. Any idea? Any other? Exactly. That is based on British rule. So mostly the British itself and British Commonwealth countries are the British territories where British have their own colonies. Those places are mostly common with the left-hand side traffic. So if you see, if you carefully look into the yellow countries, most of them are either British colony or British Commonwealth countries. So based on that, traffic pattern are different. All right, now the real example from the scratch that we can do with VISSIM. So I believe that would be interesting to you. First thing is link. The first option is we need to create a link, which is basically the road itself. And on that link, then we'll be discussing as we'll be moving forward. You can see how we can create a link, or how we can create a connector, or how we can shape or reshape a link, etc. All right, so after the link, we have activity lesson 2-1, and from there we'll be practicing these exercises. Where we'll be creating a link, we'll be creating a connector, or we'll split a link or multi-lane link, etc. And that's under activity lesson 2-1. And then activity lesson 2-2, we'll be discussing about the connector, how we can draw a connector. The main purpose of connector is it's self-explanatory by its name. Basically, connector meaning is it connects to link, right? So when we need to connect two links, we can do that one with the connector. All right. And then here we'll continue our practice with the drawing a link or drawing an extra lane, and add that one with those connector. All right. So to do that one, let's go to our activity lesson 2-1. Same. If you follow the folder, if you go to the if you go to chapter 2, and from there activity 2-1 links, and just drag and drop it into your VISSIM instance. All right. So Before doing this real example, as we discussed a bit about the right-hand side traffic versus left-hand side traffic, so there's always a confusion which one you should follow. Basically, you should follow your own jurisdiction's rule. So for example, in Bangladesh, most of the driving is right-hand side traffic. So first you need to change the parameters. So to change that one, go to base data and network settings. And from here, look for the vehicle behavior, which is the first tab. And from the first tab, you can see this traffic regulations, right-hand traffic, left-hand traffic. Okay, so for Bangladesh, that is right-hand traffic, so which is already selected there. You can also change some of the units from here. So if we go to the third tab, units, so in Bangladesh, most of the units are in standard unit, SI unit. So in that case, you can select all metric. In USA, most of the units are in imperial unit or miles or feet, etc. So in that case, in US, we are mostly using these unit parameters. And for Bangladesh, you can change that one from imperial to metric. So either you can also change each one individually. But good thing is that either you can choose any of the options or imperial or all metric, all imperial directly from here. All right. Okay. Now go to our first exercise, task 1. So task 1 is we need to create a link from point A to point B. We need to create a link. The first thing is to create a link. The first object that we need to choose is link from the network object. So just select link. That's the first thing that we need to choose. All right. Now we can create a link two ways here in the network editor. And in VISSIM, the hotkey is control key. So anything that you need to draw, you can do that one with the control key. So control key is the hotkey for VISSIM. All right. So now after selecting the link, hold your control key and hold your right click on here on the A point and drag your mouse all the way to the B. And now release your right click. And it will open up this window for the link. It is asking for some additional parameters or additional info. We don't need them right now. Just click OK. And dang, you are done with creating your first link. For this one, I'm showing this again. Make sure you select the link under your network object window and now hold your control key and hold your right click of your mouse and drag your mouse all the way to point B and release your mouse. You can also do that one in another way. So on a point, just right click and add new link. You can also do that one, add new link. So it is asking for some info. Just click OK. So it automatically adds a link there. And now what you can do, you can just drag this point all the way to point B. All right. Now, next is we need to create a link and we need to create or add one intermediate point at this midpoint. So first thing is we need to create the link from point A to B. And now here exactly at the middle, we need to add a point. So to do that one, just hold again. In VISSIM, the hotkey is the control key. So hold the control key and just right click here. So it will add one intermediate point here. Now you can drag it at this point. I'm showing it again. Just create a link. Make sure you select the link and hold your control key and right click there. And now you see. All right, now here we can see we need to create that set point. However, the starting point and ending point should be straight. So same thing, create the link and add few more intermediate points, one intermediate point here, another intermediate point here, and another intermediate point here. Now we need to create the sag at the middle, keeping the starting point and ending point straight. All right. Any questions up to this task number 3? Create a link, add intermediate point, or add multiple intermediate points. Or are you following me what I am trying to say or what I'm trying to show you? All right. Okay, so at any point, if you have any questions, again, just unmute yourself or you can type it here in the chat. So don't hesitate to ask questions. All right. So sometimes you can get the best thing from your question. All right, so now we'll do the same thing here. However, here we can see the link is curved. Instead of straight, the link is curved. So we can do that one. So create the link first and add those intermediate points. One intermediate point here, here, and another intermediate point here. Now we can move this one. All right, now to create that curve, what you can do, select the link, right click, and from here, you see generate spline, select that one. And now it is asking for how many intermediate points I would like to add. Intermediate points is basically between the section or on a section between the 2 points, VISSIM will automatically generate extra intermediate points. So for example, this section is bounded by this this point and this point, right? So here, if I put 3, then VISSIM will add 3 more intermediate points between those two. Again, 3 more intermediate points between those two. So those are the intermediate points. So if I click OK, and now you see 1, 2, 3, and here between those two, 1, 1, 2, 3. So in that way, it will create a curvature. If you add more intermediate points, so for example, instead of 3, if I add maybe 9 intermediate points, then that would be more smoother. You see, more smoother. All right. One more thing. So if I'm going a little bit faster or slower, let me know. So in that case, based on your feedback, I'll try to adjust my speed or adjust my pace. All right. So next option is now we are done how or we know how we can create a link. Our next option is how we can create a connector. The main thing of the connector is to connect to two links. So for example, here we have link number 1 and link number 3, and we need to connect that one with this connector. So here in VISSIM, good thing is that we don't have another feature, exclusive feature for the connector. Connector is pre-built within your link. So even with link, select the link and do the same thing from link 1 to link. Same thing meaning what? Hold the control key, right click here and drag your mouse all the way to point P. Okay. So up to this point, you can see it's still link, and on the right side, it says add link, right? But immediately when I snap this one on another link, immediately it says add connector, and it changes color from blue to pink color. So from there, we can also confirm that, okay, this is connector, not link. So now if I release a right click and control, it is asking for some additional feature or additional info. So just click OK. And this is your connector. Again, hold your control key and start from anywhere from this link, not outside. You must start your connector from one link and you must need to end that one on another link. So start your connector from here. Still, that is the link because that is not snapped with another link. So just move it here and you see that's connector and click OK. Here, under the task, it also has its own description, how you can create the connector, hover over a position, click and hold, right click, and release at point B, etc. All right. Now here, this is task 6. We need to create the same connector, but that is, instead of that is pure horizontal, that is oblique, or that is inclined. So do the same thing, connector, click OK. And here we need to repeat the same thing, but the connector is not straight, that is curved. So right click, and now instead of clicking OK, under this connector window, the second option, intermediate points, by default that is 0. Now maybe we can put some intermediate points, 5. So what VISSIM will do, it will automatically add 5 intermediate points between two existing points. So now if I hit OK, now you see VISSIM will automatically generate extra 5 intermediate points, and it is automatically making that curvature. All right. Now we can repeat the same thing here. Here the task is a little bit different. So up to this point, this is one directional road, and here we have two directional road, this way versus that way. So we can do that on same way. First, create the connector here. It is asking for intermediate points. By default, it is taking the last value that I put, 5. Now do the same thing from link point C to point D, and click OK. All right, our next task is to draw a multi-line link. So that is pretty much straightforward. First is we need to draw a link. And when we are done, just select the link. And on either side, at the middle, you see there's a wide yellow bar. So you can just drag as many lane you want on the top or on the bottom, whatever. So you can do multiple lane in that way. So now it has total 3 lanes. And if I open the window of this link, here you will see it says the total number of lanes 3. You can also change the number from here, and you'll see each lane's information here at the bottom. 1, 2, 3, total 3 lanes, and each lane's width is 12 feet. In that way, you can do multi-lane link. Okay, now what if you need to split a link? So let's create a link first. Let's create a single lane link. Now we might need to split the link, right? So what we can do, just at which point you might need to split, right click and split link here. And splitting means what? When you link, basically we divide a single link into 2 links, right? So here, this is link number 10, and this is link number 11. You see, now we have 2 links. Initially, it was a single link, and now we have 2 links, link number 10 and link number 11. And as per the definition, those 2 links are connected with this connector, link 10,005. That is connector. We can verify that one by seeing the color, pink color. So pink color is connector, and blue color is link. Another way we can verify that is a purely connector by observing their values. Any kind of link or link number starts with just normal value from 1, 2, 3, 4, 5, 6. Those are just normal values. Any kind of connector starts with 10,000. 10,001. If you see some link is numbered as 10,000 something, 10,001, 10,002, or 10,003, whatever, 10,000, those are basically connectors. So if I go to the link list, link, right click and show list, it will open up this list. And from here, you see these numbers 1, 2, 3, 4, 5, 6. all these numbers up to 48 are basically purely link. And from here, 19, 10,000, 10,001, 10,002, all these are basically connectors. So you can also verify that one or check that one by just observing their number. Okay, so anything with just normal number, those are link, and anything with number associated with 10,000, those are connectors. All right. So as we split the link, so VISSIM will automatically split the link and it automatically adds a connector connecting those two links. In that way, we can split the link. Again, select the link, right click and split. You see, it split the link here. All right, now here the task is we need to split the link and we need to add one more lane at the middle. So same thing, first draw the link and we need to split the link at point C. We need to split the link at point D. And now we need to add one extra lane into the middle lane, into the middle link. So again, draw the link, split the link here, split the link at point D. Now just add one more lane in the middle section. All right. Now here we need to complete this task. Here you see, for example, this is the freeway highway, and there is a ramp coming from point E, and we need to merge that ramp with the highway. So the task is simple: draw the link, split the link at point C, split the link at point D, add one more lane here, and now we need to add a connector from this link number 16 to link number 18. So to draw the connector, what we need to do, hold the Control key and start from anywhere of this link and go all the way there. And you probably notice VISSIM will automatically add connectors connecting those two lanes. So if you want to connect or to drop the connectors just on the first lane, you can do that one. You see there's a white yellow bar. So just drag and drop it here. Now you see it is just a connector connecting one lane versus one lane. If you want to add a nice curvature like this one, double click the connector and number of intermediate points, put some values. Maybe I can put 5 and you see it automatically creates that nice curvature. All right, any questions regarding the link or connector or any of the tasks from task 1 to task 13 that we have practiced? Any questions regarding that one? Okay, seems like there is no question. So let's proceed with our next exercise. Now, let's go to our activity lesson 2-2, and there we have an exercise to complete this intersection. So activity lesson 2-2, and there's an on-ramp exercise that we need to complete. Same thing, just drag and drop it here. All right. So here, same thing for this exercise. We also have a written instruction here. You can, if you can, I mean, you can directly follow that instruction. Okay. Now here our task is to complete this exercise. This is intersection, and there's a ramp. That ramp connects that highway, which is link number 23, and we need to complete that one. All right, so first, okay, let's start from here, or maybe we can start. Okay, so let's draw a link from point B, yeah, up to that point. All right. Now we need to, if we need to realign, this link, what we can do, we can add some intermediate points. Okay, so by dragging those intermediate points, we can realign the link. Okay, you see now that is properly placed. Now, from point E to point B, we need to create a connector. That is a connector. How can we verify? By observing the number, right? If I hover over this link, it says the number is 10,002. So any number with 10,000 associated with 10,000 is connector. So this is connector and this is link. So we draw a link here. And now we need to draw a southbound left turn from this link. So first, we need to add one more extra lane for the left turner traffics. To add that extra left-hander traffic, what we need to do first, we need to split the link here. And now we can add one more extra lane to the left. And from that left lane, we can add one connector to that link number 7 as a connector for the left-hander traffic. So to do that one, same thing, hold Control key, right click, and come here all the way there. Click OK. And we just want a single connector from a single lane to the single lane. So it is VISSIM by default create a connector from this tree link to one lane, right? But we don't want that. We only want a connector from a single lane to a single lane. So what we can do, just drag them and move this one to the leftmost lane. All right, now double click this one and put some intermediate point, maybe 7. And you see, this will automatically make that curvature. Okay, so here we also have connector. We have completed that one. And we need to draw one more lane to the right. And from that lane, we need to draw another lane and another connector. So we need to split the link here. We need to split the link here as well. And now what we can do, we can add one more lane to the right. And now here, from the color, we can see that is a link as blue color. So we can draw a link from this point to all the way there. And we can add some intermediate points just to realign the link. Or what we can do, right click and generate a spline, and VISSIM will automatically do that curvature for us. And if I move this one, sorry, and now this one. All right, okay. Now here we are done, and now from the color we can see that is a connector. So we need to draw a connector by connecting link number 9 with link number 26. So I'm just adding a connector, and that is from that connector is from rightmost lane to that lane. So I just drag that one, and we need to do the same thing into that point. Maybe you can put some values there, so VISSIM will automatically add a nice curvature. Looks good. And one last thing is need to extend this one all the way to here. We can add few intermediate points just to realign the curvature. All right. Now here, this is basically part of the main line. So this is one extra lane on the main line. So we need to split the link at point G. We need to split the link at point F. And we need to add one extra lane to the right. Now, at this point, we can see this link number 7 and link number 28 is connected via a connector, right? So we can just draw a connector from this point to that point. And by the same way, just dragging this one, and that is from the first lane to the first lane of link number 28. In that way, we are done with this exercise. All right, now you might have a question on the last exercise. When you drew something, if that is a link, that will automatically show up as blue, and when that is a connector, that is automatically show up as pink color. But here, um, either that is link or connector, all show up as a gray color, right? So you can define the color under your edit graphic parameter setting. So to replicate this one with exactly with our last exercise, what we can do, so under the link, and there's an option edit graphic parameter, this one. If you click that one, and from here, fill style and drawing mode, use display type, change that one to use color scheme. It will open up this window. Just click OK. Or for this one, actually, don't need to do that one. Fill style, solid fill. I'm looking for a use constant color. Okay. So from there, drawing mode, change this one. By default, that is use display type, change that one to use constant color. Okay. Now for the fill color, by default, as we are working under the link, so fill color meaning fill color of the link. So this is for the link. If I click this one and change this one to blue, maybe this blue. All right, so now our link is blue and our connector should be in pink color. If we would like to replicate the same thing from our last exercise, at the bottom, you see connector border color or connector fill color. So you can change the connector fill color to pink. And now you see, now we have link in the blue color and connectors are in the pink color. Just in case if you'd like to do the same thing from your last exercise, definitely you can change the color or you can choose the color by your own. Instead of pink, maybe you can put some orangish color or whatever. You see now. So that is a good thing. So if you put two separate colors, one is for the link and one is for the connector, then from there you can easily identify, okay, which point you have link, which point you have connector, or where if you're missing a link or if you're missing a connector, you can easily identify by just observing the color. All right. Here still you can see some pink color. Do you know why there's a pink color? Here still you can see some pink color. Do you know why we are still having those pink color? There's a question, can you merge link and connector to be a link only? No, you cannot merge them to be a link only. So what you can do, two ways you can do that one. So for example, maybe you have a link here, and if I split the link, so it is splitted and split the link into two, and it has a connector. If you really need to merge them, one good feature that is available for last 3 to 4 years. What you can do now, we have undo option in VISSIM, so you can easily undo, just simple undo method as we can do into any Word document. Control Z. If you hit Control Z, so it will automatically delete the connector and create that single link. That's one option that we can do. Or if you don't have that undo into that option, or if your undo is too far away to merge that one to the previous version, so what you can do, just delete one of them, and you can extend this one. That's another way that you can do. All right. So now, if we continue our, yeah, the pink color is from the background image. Exactly. All right. Now our next thing is desired speed decisions. So when we draw the network, our first option is draw the link. We are done with drawing a link, and we know how to draw a link, or how to draw multi-line links, or how to draw connectors, right? So when we are done with that one, next thing is we need to provide the appropriate speed guiding decisions. So those are basically based on desired speed decisions. So we can provide the software, or we can provide the VISSIM to guide the vehicles or to guide the traffic to run under a certain speed limit conditions. All right, so the speed limit of a certain road, or what we call it here is desired speed decisions, is the allowable speed limit that the jurisdiction or the corresponding authority allows a certain vehicle to run or to drive under that specific speed limit options on a certain road. Now, the question is, so for example, we are going to build a new network, or we are going to build a new road in the real world, or we have a road, how we can define the desired speed of that road. So for example, we have policy road, right? Between our halls and between our administrative building, we have a policy road there. Now the question is how we can define, or how we can get, or how we can calculate the desired speed decisions in the real world. So as a traffic engineer, if I tell you, okay, this is the road, you need to identify the desired speed decisions. What would be the desired speed decisions of this road? How we can do that one? Is that 25 mile per hour, or 40 kilometer, or 50 kilometer, or 60 kilometer, or even 80 kilometer? I don't know how we can get or find the desired speed decisions or desired speed of a certain road by calculating LOS V over C ratio. LOS V over C, that's far away, because to calculate LOS V over C, first you need to have the vehicle count, vehicle capacity. V over C means vehicle over capacity. So for the capacity, first you need to have the speed info. So the question is how we can calculate the speed of a, or desired speed of a certain road. Any idea? Based on banking angle, stopping sight distance? No. Let me give you a hint. So to get the idea, first we need to do survey, traffic survey, or speed survey. So for example, for the policy road, we are going to explore what would be the desired speed limit of that road. First, we need to do the traffic survey or speed survey of the vehicles of that road. That's one of the hints. Now, think how we can calculate the desired speed decisions of that road. Or let me give you another hint. So for example, from the survey, we have the speed profile of all the vehicles there. Based on the traffic demand and congestion, maybe how we can get the traffic demand of a road. Or how do you know what is the traffic demand of a certain road? Okay, so let's say, for example, let's assume we have the speed profile of all the vehicles driving over a certain road or over policy road, right? So you have speed profiles or speed data, spot speed data, or space mean time speed, or whatever, you have speed data. Now, the question is, which parameter from your speed data you will consider for defining the desired speed decisions? Is that the minimum speed, maximum speed, mean speed, median speed? Which speed you will consider as the design speed of that road? Which speed and why? Minimum speed, maximum speed, or mean speed, median speed? Any idea? Space mean speed. Space mean speed is basically the speed, and now from that speed, what statistical parameter you will consider? Will you consider the minimum speed, maximum speed, or median speed, mean speed, whatever? Which one? Or what is your justification? So for example, on that certain road, you see maximum speed is maybe 80 kilometer per hour. Will you take that one as the desired speed decisions? Or probably you can say minimum speed is maybe 30 kilometer per hour. Will you take that one as your desired speed decision? Somewhere above mean but below maximum to not hinder travel mobility. Yeah, you are technically correct. So basically, you're saying somewhere between close to 50% to 100%, somewhere between. Technically, we're correct. Any other, I mean, could you please narrow down your range? Yep, 85th percentile speed. So when we have a survey data, and from that survey data, 85th percentile speed is our design speed. The reason is that we are not going with the mean value, neither we are going with the maximum value. The reason is that if we design our road with the maximum speed, that means we are encouraging our drivers to run at their maximum speed. So our design speed is 85th percentile speed of a certain road. Okay. So from there, now we know what is our desired speed, and we can assign that specific desired speed on a road. Even we can also assign that specific desired speed into our VISSIM model. All right. So to do that one, we have exercise demo 2-3. And from there, we can check this one. And we can put some extra exercise under 2-4, and we also have desired speed distributions there. So let's go to our activity lesson 2-3, and from there we can see how we can define our desired speed decisions into VISSIM. So demo 2-3.inpx. All right. Here you see there's a link here from this is link number 3, and this part from this point all the way to here, this is school zone, and on this school zone speed is restricted. So for example, on this school zone speed is allowed up to maximum 20 mile per hour. So when vehicle appear on this very specific point, we need to guide the vehicles with that very specific speed, or with the very specific speed profile. Okay. So we already have a desired speed decisions here. For the experiment purpose, let's delete this one. All right. Now, desired speed decisions is the second item from your network object window. So just select the desired speed decisions from your network object window. And here we need to place that one here again using the hotkey of the VISSIM, hold control and right click there. It will open up this window. Now it is asking for a few additional information. Under these options, vehicle class with desired speed distributions, right now that is blank. We need to add the vehicle class or vehicle speed distributions under this option. So right click and add. It will automatically add vehicle class car. Car means just normal regular car. Either that could be sedan, that could be SUV, or that could be van, etc. And we can also add one more extra class, right click and add HGV. HGV means heavy good vehicles, or in simple, HGV means truck. Okay. So it is now adding by default adding two vehicle classes, vehicle class car and vehicle class truck. And under the desired speed distributions, it is adding some desired speed distributions from the speed distributions list. I'll show that one in a moment. Right now, it is only showing the corresponding number of the desired speed distributions, and from the number, we cannot explicitly say what those numbers mean. For example, 3, 3, and if I see click the drop down, and from the drop down, and even those number is not self-explanatory. So with this one, just click OK for now. Now we need to check the desired speed distributions number. So to check that one, go to base data, and from here look for the distributions, and under distributions look for the speed. So base data, distributions, speed. Okay, so when you click that one, it will open up this window, and now here we can see 3 means the speed profile, where lower bound is 2.49, upper bound is 3.73. Yeah, definitely. Is there, you can add rickshaw for the context of Bangladesh, or even you can add auto rickshaw, CNG, TomTom, whatever. But for that one, you need to know the vehicle characteristics, physical characteristics, basically the acceleration profile, deceleration profile. You need to know the vehicle's physical characteristics of that very specific vehicle. So for example, for the rickshaw, first you need to know what is the acceleration profile or what is the deceleration profile of that specific vehicle. Once you know that one, then you can easily add that one. So just as a supplement to your question, if I open the vehicle class or maybe vehicle type, for example, this is car. If I open this one, you see functional distribution. If I go there, you see maximum acceleration car, desired acceleration, maximum deceleration, or desired speed profile. So first you need to know the maximum acceleration, desired acceleration, maximum deceleration, desired deceleration, and desired curb speed functions for that specific rickshaw or CNG, whatever. Also can add their geometry. Yeah, definitely you can add their geometry, but first you need to know their functional and distributional physical characteristics. What is their acceleration profile, deceleration profile, etc. Because, for example, if you add rickshaw here and use the same acceleration profile of the car, then your rickshaw will be driving as speed as your car, which is not realistic. So first, you need to have very well-defined physical characteristics or functional characteristics of your vehicle type. And once you know that one, then you can add that one under here. So functional distributions, base data distributions, or functions from here, then maximum accelerations. And once you know the acceleration profile for your rickshaw, you can add this one here and you can give it a name. Maybe this is rickshaw. Okay, now you have rickshaw, and definitely you put your values here. Probably that could be another good topic for your research or for your undergrad thesis. Thank you, Anika, for the clarification. For the people who don't know about the this specific vehicle type. All right. So from here, once you know all the vehicle profile, the acceleration deceleration profile, you put this one here, and under the vehicle type, now you have rickshaw. You can give it a name, and under the maximum acceleration, you can select rickshaw acceleration profile, and in that way, you have that full customization or flexibility you can do in VISSIM. That's the best part of VISSIM. In VISSIM, actually, we have lots of flexibility and you have lots of customization option. Okay, going back to our previous topic. So here, speed distributions, our intended speed distribution is 20 mile per hour. So that is basically average speed. So that could be probably this one, right? 18.64 to 21.75. So this one is 20 mile per hour. And we will also need another one, 30 mile per hour. That could be probably this one, 30 mile per hour. All right, so when I put the name, and now if I go to this one and desired speed decisions, if I double click this one, now from the desired speed distributions drop down, now under 20, we can see, okay, 20 means 20 mile per hour. We can select that one. For that truck, we can select this one as well. Now click OK. Now that means any vehicle, those are driving here, once they reach into or and they pass over this point, from this point, they're supposed to slow down their vehicle and drive at 20 mile per hour. All right, to test this one, let's run the simulation. So from the simulation, we can get our real result. So for that one, I'm going to slow down the simulation a little bit so that you can follow. So to slow that down, simulation parameters, and from here, instead of simulation speed maximum, I'll be running the simulation at some factors. As I open this one, let me explain what this means. Simulation speed has been set to maximum, meaning the simulation will utilize the maximum speed or maximum resource of my CPU, and it will run the simulation at that maximum speed and that it can obtain from the CPU. However, I can regulate the speed. Instead of using the maximum one, I can regulate some factors, regulate the speed with some factor values. So for example, if I use factor 10, meaning 1 second or 1 simulation second is equivalent to 10 simulation second from the real world. All right. So if I put it 5 now, meaning 1 simulation second is equivalent to 5 simulation second from the real world. Now hit OK. Now let's start the simulation. Okay, now I can see vehicle is running. Okay, now pause. One thing, once the simulation is running, you can pause by clicking this second simulation single step, this icon. If you click that one, that will pause. If you click again, then it will run, or it will run the simulation with 1 incremental second. So for example, if I click one more, it will just progress with 1 extra second or 1 extra tenth of a second. So you can play and pause with this one. If you click and hold this one, it will continue. Or there's another shortcut option. While simulation is running, you can pause this one by simply pressing your space bar. Okay, so right now, if I instead of clicking this one, I'm pressing my space bar. You see, if when I just single click my space bar, it will uh, run the simulation with one incremental time of the simulation period. Okay, now let's check the speed of this vehicle. Okay, so simulation parameters. So for example, here simulation speed. If I put any values there, that means that corresponding second. So for example, the simulation speed factor is 5, meaning 1 second or 1 second in simulation or 1 simulation second is equivalent to 5 seconds from your real world. That means if you have to tell 1 hour period from your world, real world, you can run that 1 hour period simulation into 60 divided 5, 12 seconds. So you can run that simulation into 12 seconds. Okay. Now, as the simulation is running and I pause the simulation, if I select this specific vehicle, and I would like to get some information from that vehicle. So what I can do, go to view, and from here, look for the quick view. So it is open up this one. You can dock it here. All right. So now if I select this vehicle, it is showing this vehicle's desired speed is 31.44 and it is running at 31.76 mile per hour at this point. So if I proceed, you see its vehicle desired speed is 31.44 because that was defined at the starting point. But that vehicle is supposed to run or supposed to slow down after crossing this one, as this mark or this crossing bar is designed to guide the vehicles with a specific desired speed decisions of 20 mile per hour, right? So if I run the simulation, it's still running with the same speed as it approaches. Still, I'm zooming in. Still, it is not passing over that one. Immediately, the vehicle hit that mark or speed decision mark. You see, desired speed decisions. Initially, that was 31 point something. Now that is changed to 19.45, meaning now it is following the mean value of desired speed decisions, 20 mile per hour. You see, 19.45. Okay. As the vehicle was driving at 31.47 or 30, around 30 mile per hour, so now the vehicle knows they need to slow down and they need to cope with the designated speed of 20 mile per hour. So what are the things the driver needs to do immediately? The driver needs to hit the brake bar and the driver needs to decelerate the vehicle, right? So immediately after hitting this one, you can see desired speed decisions is 19.45, and as the vehicle was driving at 31.47, and under the acceleration profile, you can see it's immediately negative. And as long as we proceed the simulation, we will see higher deceleration value, meaning higher negative acceleration value. Right now, that is negative 0.80, right? So if I proceed, you see it is trying to slow down. Now deceleration value is 2.14. 2.80, and it is slowing down. Here you see the value 30, and this value and this value, if you follow those two, it is slowing down. You see 28, 27, and it is now it is deceleration value is 3.36, right? So it is trying to match with the desired speed decision. So here two speed. One is desired speed and another one is actual speed. So once it tries to match the desired speed decisions, okay, so now it almost matches with the desired speed decisions. You see, now it almost now it is running with the specific desired speed decisions. So it is taking that much time to match that specific desired speed decisions. And you can see that one from this uh, graph as well. On the graph, you can see the red line is your design speed and the blue line is your actual speed. So you are driving at 30 miles per hour, and at this point, you are guided to slow down your speed to 20 miles per hour. You see that this is 20 miles per hour, but you are not robot, right? You are a human being. So you need some time and space to slow down your vehicle from 30 to 20. And you are slowing down, and probably at some point you can attain your desired speed. Here, you can see at this point, or probably at this point, that vehicle is able to match the desired speed. So that's why when you have a desired speed decisions, it needs some space and time to slow down and match the posted speed limit. And with that one, it is continuing. And at some point after, for example, this is another desired speed decisions 30 because school zone is off here. So school boundaries from this point to all this point. After this point, there's no school restrictions. So from this point, the vehicles are supposed to go back to their normal speed. So we can follow this vehicle. This vehicle is supposed to run at 19.25 as it's still within the school boundary or school zone. Immediately it hits this new desired speed decisions. If I proceed the simulation, still 19.25, still 19.25, probably next progress, timestamp progress, it will hit that one. Still 19.25. Now it hit that desired speed decisions, and you see immediately desired speed decisions is 31.05. And as the vehicle was driving around 20 miles per hour, now it needs to speed up to match with the 31.05. That's why you see the acceleration profile is positive and it is accelerating more. You see 4.8 to 5.47, and it is 6.7.44, and accelerating more to match with the new desired speed decisions. And at some point, it will now here at some point it will match with the desired speed decisions, and for that one it is still needs some space and time. And from the graph we can see at this point this is the actual speed, blue color. It was running at somewhere around 20 miles per hour, but when it knows about the new desired speed decisions 30 miles per hour, so it is accelerating and it is speeding up, and at some point it matches the desired speed decisions, and then it continues with the desired speed decisions, and it is doing the same thing. Now it almost matches, and now it is continues with the desired speed decisions. So that's the thing for the desired speed decisions. You can anytime you can place the desired speed decisions on a certain link, certain area, or certain zone, and you can get the traffic in that way. Any questions regarding the desired speed decision? All right. Now there's a seems like there's no question. Now there's a question for you. So for example, on a certain road, maybe you can see that this observed speed is too low. Maybe because of the long queuing or long jam, you can see on maybe on the Nilkhet road, you can see that this observed speed is maybe around 10 kilometer per hour during the peak time. Vehicles moving pretty slowly because of the queuing or jam. So in that case, what would be the desired speed decisions for that certain section? The observed speed that we observe from our real world, from our survey, or the actual speed that we obtained from the free flow speed or 85th percentile speed, whatever, which speed we need to design for a certain section of the road where we can see a very reduced speed on a certain link. So I'll probably give you 3 to 4 minutes to discuss within yourself, and then you can let me know after 3 to 4 minutes about what would be the speed, or what would be the desired speed or design speed for a certain road where we can see a very reduced speed due to the queuing or congestion. There's a question. Different vehicles desired speed is different. So for example here, maybe for the car, my desired, let me stop the simulation. Okay, so here, maybe for the car, our desired speed could be 30. For the truck, desired speed could be 20. So the value is based on how you'd like to guide your vehicles. Maybe for the truck should go a little bit slower or car should go a little bit faster. Depends on your roadway characteristics, depends on your lots of things. So how you can define, you can based on your jurisdiction's justification or from based on a research. You can also add bus here. So even maybe for the bus speed, but should go maybe a little bit slower. You can define a different speed profile for the bus as well. The desired speed should be lower than 85% due to the physical constraints of the congestion queuing, I think. Uh, might be I'm just discussing the typical condition, what we can do in the free flow mode. So the 85% is basically from your free flow mode. But if you would like to consider the physical constraint congestion, then I mean, under the Bangladesh constraint, probably desired speed should be a little bit different. But the thing that I'm saying that's based on purely academic discussion or based on North American perspective. All right. Okay. Do you get your answer, Nahin and Oishik? All right. Uh, Now the question is, so for example, on this certain road, because of the long queuing, long jam, from the observations, you can see on this road, maximum time, the speed is pretty low. Maybe it could be close to the Nilkhat area, and your speed is maybe even 5 km/h or 10 km/h, right? So now the question is, as from our observation, we can see on this certain section, our observed speed is 5 km/h or 10 km/h. In that case, do you need to provide the desired speed decisions following the observed speed? So for example, this one, if our observed speed is 5 km/h, in that case, do we need to provide 5 km/h here? Or we should yet we should continue with our desired speed from our guidelines or from our roadway characteristics or some other else. So which one should be the desired speed for a certain section where we observed lots of queuing? The observed speed or the actual calculated speed or the what else we can say? The anticipated speed or probably the theoretical speed. Which speed that we should provide here in the VISSIM? The observed speed or theoretical speed? Anyone? Okay. Uh, okay. Observed. Yeah, all of you are correct. Observed speed. Now the question is why the observed speed? Why not the theoretical speed? Or I'm not going to say correct or wrong right now. Now, next question is why the observed speed? Why not the theoretical speed? Or if someone says theoretical speed, why the theoretical speed? Why not the observed speed? Any justification? In traffic, 95% cases in traffic are based on justification. So why the observed speed? Why not the theoretical speed? Or instead of typing, probably you can unmute yourself and speak up. Any justification? Or is there anyone who is probably thinking that could be the theoretical speed? In which we try to capture this scenario. All right. There's one justification, another justification. All right. The desired speed decisions are the speed that we are going to dictate to the vehicles that will be based on your theoretical speed or the posted speed of a certain road, not the observed speed. The reason is that, for example, here our observed speed could be 5 km per hour, right? If we put our desired speed decisions as 5 km per hour, then VISSIM will take that one as the desired speed decisions and vehicle will by default drive there at 5 km per hour. However, in that case, VISSIM won't calculate the delays associated with that queuing. All right. So 5 km per hour is not the expected speed, right? So vehicles are driving on that certain section at 5 km per hour because of queuing, because of jam. So that's why if we have something similar to that one, we need to put the actual speed as the desired speed. And then if there is any queuing or as per the Rakib Khan's comment, capture the base scenario or real scenario, we need to adjust the model in that way so that it will, or the vehicles are bound to pass that certain section with a lower speed so that that will count under your queuing. Meaning any kind of speeding or some other adjustment that we need to do with the vehicle calibration and driving behavior. So to capture the base scenario or to capture the real scenario, we need to do that one with the calibration, model calibration. All right. So for example, we here the posted speed is 20 km per hour. Instead, we can see our observed speed is 10 km per hour. The gap 10 km is due to the congestion or due to the queuing, right? So when we put our desired speed decisions here 20 km per hour, and through our model calibration, if we are able to run the vehicles if we are able to mimic that queuing congestion here, vehicles will automatically slow down. And in that case, VISSIM will automatically calculate the congestion, automatically calculate the delays associated with that congestion. I have to excuse myself and leave in 5 minutes. It's time to celebrate New Year's. Yeah, Happy New Year. All right. So in that case, you have to VISSIM will automatically calculate what? VISSIM will automatically calculate the speed differences based on the actual speed versus observed speed, and that those speed differences are associated with the queuing or condition. So from that, VISSIM will know, okay, these speed differences or this delaying are due to the observed queuing or congestion. All right. So that's why when we need to put anything regarding the speed, those speeds should be based on your actual speed, theoretical speed, calculated speed, or desired speed, whatever, not the observed speed. All right. I know it's a little bit tricky and confusing. So just in case, before moving, also won't it be confusing for regular drivers if we keep the desired speed variable on observed speed? Uh, Drivers never drive into the observed speed. I mean, desired speed is basically based on the free flow speed. What would be the speed? For example, on a certain road, what would be the speed you will be driving when you get that road empty, right? Or with fewer traffic. Versus observed speed is kind of forced speed. That's not your regular speed. So drivers won't be confused. Drivers will always try to drive at their desired speed. However, when there is congestion, they'll automatically forced to slow down their speed. That is the observed speed. Observed speed is not the intended speed or desired speed of the drivers. So those are kind of forced speed. And we need also do that one here in the VISSIM to mimic that one by doing model calibration. So drivers won't never be confused about the observed speed. So those is some kind of forced speed. Okay, there you can see there's a congestion, and definitely you cannot drive at 40 mile per hour or 50 mile per hour because of the congestion. Okay, before moving to the next topic, I know this is a little bit tricky and confusing. So I can still spend some few more minutes on this topic, just in case if you have any other confusions, questions regarding the observed speed versus intended speed or desired speed, posted speed, all are same basically. I mean, intended speed, posted speed, design speed, all are kind of same or similar. So just in case, do you have any questions regarding this one? Why we need to put the desired speed, not the observed speed? All right. Now, if you remember those speed here, these desired speed distributions, we can get it from base data distributions speed, right? And this opens up this desired speed distributions, this one, right? Can you give a short summary of the various speed? Okay, so here basically we have two types of speed. One is observed speed, the actual speed you can see either from the real world or, I mean, the actual speed that you can see, that is observed speed. And another one is theoretical speed or posted speed or the expected speed or the desired speed, whatever. Okay, so one is theoretical or ideal speed versus another one is observed speed. To make this simple, when you don't have any congestion or when you are driving at your free flow speed or when you are driving in an empty road, in that case, your observed speed should be close to your design speed or intended speed. That's the summary. But when there's a long queuing or long congestion, at that time, your observed speed should be substantially lower compared to your intended speed or desired speed. Okay. Now, from the base data distributions, from here we open up this speed profile, right? Speed distributions. We can also define the speed distributions or by ourselves or modify an existing speed distributions. So let's modify this one 20 mile per hour. Or maybe we can modify 30 mile per hour, right? Okay, open this one. So this is a purely linear speed profile starting from 30 all the way to 36. We can see lower limit is 29.83, upper limit is 36. We can modify this one, probably lower limit 28, upper limit might be 37. You see now lower limit 28, upper limit 37. However, our speed profile is not purely linear, right? That is some kind of curved. So for example, as from our previous discussion, our desired speed is based on 85th percentile speed, right? So on this curve, our 85th percentile speed or our 85th percentile should be close to the speed of 30 mile per hour. Okay. And here, the curve you're seeing that is based on CDF curve or cumulative distribution function. I'm not sure how many of you are familiar with the cumulative distribution function or CDF. So that, in short, the simple thing is that it starts from 0 and all the way to 1, or in percentage, 0% to 100%, right? So that means here we can add some intermediate points and put our percentile value. So to add the intermediate points, same thing, hold Control key and left click. So you can add as many intermediate points you want. So for example, for the sake of our discussion, our 85th percentile speed is 30 mile per hour. So y-axis is your percentile value and x-axis is your speed value. So 85th percentile speed should be somewhere here, right? And that should be equivalent to 30, right? This one here. So let's reduce some of the values for the sake of this exercise. All right, you can move this one here. Okay, so our 85th percentile speed somewhere here, 85th. All right, this is 85th and 30, right? We can see now here, if I hover the mouse over there, it says 30 meaning speed and 0.85 means 85th percentile, right? So this is our speed profile. However, lower speed is 28, upper limit is 37, with our 85th percentile speed is at 30 mile per hour. Click OK. In that way, you can modify your speed profile. Or from your study, from your survey, if you have more intermediate points, you can add more intermediate points. Maybe in that case, I'm just randomly placing some extra intermediate points here. Right? So you can prepare your graph by yourself if you have intermediate points. Once you are done, you select this one again, and on the right side, you can also see the values. On the x-axis, you can have the speed profile, and on the y-axis, you have your CDF values, CDF function values that starts from 0 all the way to 1. Even though if you have this direct result from your Excel sheet, you can directly copy and paste it here, and VISSIM will automatically create that graph for you. In that way, you can define your own speed profile. So here we edited an existing speed profile. So you can also create your own speed profile. You see there's a plus icon, just hit the plus icon and give it a name, maybe 40, maybe 35 mile per hour, where our lower limit could be 32, upper limit could be 38, right? And now 32 and 38, and probably our 85th percentile speed should be 35. So 35, we can add one intermediate point. This could be, this is 85th percentile speed, 35, somewhere here, right? Okay, or if that's a little bit tough for you to snap that exact point, what you can do, just add one intermediate point. Now click OK. And from here on the right side, you can just edit the values. So we know the speed should be 35 and this value should be 0.85. Now VISSIM automatically create that exact point for you, 35, 0.85, meaning 85th percentile speed is at 35 mile per hour. And we can now we have that 35 mile per hour, and we can define that one here using 35 mile per hour. What does setting 85th percentile speed mean? Does it mean 85th of the simulated course will follow the rule? No. Here, this is the desired speed limit. This is the posted speed limit of a road. So on a road, we have posted speed limit, right? What would be the allowable speed limit of a certain road? So desired speed decisions is the allowable speed limit of a certain road, meaning all vehicles are supposed to follow that desired speed. All right. We are done with this one, desired speed decisions. All right. We can also discuss this one here, sync option. So in the VISSIM, we have sync option. So for example, if I open the link list, and if I select any of the link, you see when I select any of the link from that table or from the list, it will automatically be reflected on the network editor window, right? Here you see network editor. If I select link to, it is automatically highlighted there, right? And vice versa. If I select something from the network, if I select link one, it is also highlighted here from the link table, right? The reason is that these two, network editor and link list, or list of that specific network object, are synced. Here you see this synced icon that is kind of similar to the Wi-Fi WPS button, sync icon. So if I turn that off, now those are not synced. If I select something from the network editor, then that won't be reflected here. Or if I select something from the network list, that won't be reflected into the network editor. So to reflect your selection from one window to another window, we need to sync those two windows. So if we turn that on, now we can see, yeah, okay, all of them are synced. Or even, for example, I'm here, and if I select this one, that is already selected there, but I don't know where that one is. Instead of zooming out and zooming in on that specific one, what we can do, just right click and zoom. So now, dang, this will automatically take you to that very specific point. All right. Now, our next option is, under chapter 2 is the vehicle input. We are done with creating our network. Now, next thing is we need to know how we can enter the volume or enter the traffic flow into the network. So we have vehicle input option, and here you see under the network object, third item is vehicle input. So through that one, we can easily input the vehicles into our network. And let's try that one. So for example, here you see the vehicle input. First, let's turn that on, vehicle input. Now, select the vehicle input, and same thing, hold the control key and right click here. When you do that one, VISSIM will automatically snap your vehicle input at the very starting point of your link. Here, this one you see is already has a vehicle input and this very starting point. And this one is the new one that I have just added, vehicle input here. So let's delete this one and work with the start given one. that was already provided. Here they created a dummy link, so that's why it is grayed out. We can also do the same thing. So let's do the vehicle input on our real link. And here we need to put some values. Maybe our vehicle is 450, right? So this is from this link number 1. And link number 1 is school zone 20 mile per hour, that one. Okay. One thing to remember in VISSIM, any kind of volume that you see in VISSIM is based on your hourly rate. So any kind of volume that I entered here, even though if I hover the mouse over the title bar, here it says explicitly says number of vehicles per hour, not per time interval. So maybe from your survey data, you have 15 minutes time interval data. You have data for first 15 minutes, second 15 minutes, third 15 minutes, fourth 15 minutes. But when you enter the value here, even though if you need to enter the values for per 15 minutes, make sure you enter the value converting that values as hourly rate. Any kind of volume in VISSIM is based on hourly rate. Okay, so for example, it's your first 15 minutes, and first 15 minutes you get volume 100. Then you need to convert that one for hourly, meaning 100 times 4, 400. You need to enter 400 in that case. All right. So when you are done with the vehicle input, then under the vehicle composition, you can select the default vehicle composition, or if you have a very specific vehicle composition, you can define your specific vehicle composition and select that specific vehicle compositions from here. Okay, now for your built network, you make sure you need to enter the vehicle inputs for every starting point. So we have one starting point here. For the westbound traffic, we might have another starting point here, right? Yeah, this is another link. So we might need to another vehicle input at this starting point. So this could be westbound traffic, right? And maybe this one is 500. Now, if we run the simulation, we can say vehicle is generating from this point. For example, if I run the simulation, you see vehicle is also generating from this point. Oh, I didn't put numbers. Okay, 500. Okay, now if I run the simulation, you see now vehicle is generating from that point. So in that way, you can define the vehicle input and at any of the either starting point, each of the starting point of your entry or of your network. All right. So under the vehicle input, we have vehicle compositions. And for that vehicle compositions, what we can check, go to traffic, and from here, look for the vehicle compositions. And by default, it is showing default vehicle compositions, which is based on vehicle type only car, right? 0.98% car. So ideally, this should be have 98% car and 2% truck, 0.02. Okay, so this could be the ideal vehicle composition. Here you have 98% car and 2% truck. From your own observation, from your own survey, if you have very specific vehicle composition, you can define your specific vehicle compositions as well. Maybe this is custom vehicle compositions, right? And custom, you might have car, truck, or bus, and maybe 92% car, maybe 5% truck, and rest of the 3%, rest of the 3% bus. So for your case, your vehicle composition could be different, and you can also define the very specific speed distributions for each of the vehicle type as well. If you think you have different speed, or you need to define different speed for different vehicle types, you can define that one as well here. So once you set all of them under your vehicle compositions, then you are ready with your vehicle compositions, vehicle type, desired speed distributions, relative flow. Relative flow means, I mean, what would be their modal share, right? Modal percentage into the road. And once you are done with that one, now if you go to your vehicle input, now you can define that specific one, custom. And under that custom, you already have those are defined. And now, if you have 500 vehicles, among 500 vehicles, 92% are car, 5% are truck, and the rest of the 3% are from the buses. All right, any questions regarding the vehicle input? Okay, so we are almost at the midway of our today's session. As the content is very vast content, so I'm just skimming through the very list description of the rest of the items. So for example, vehicle route, under the vehicle route, you can define which route the vehicle should follow. So for example, starting from this way, there might have multiple routes at the downstream point, right? So you can define their vehicle route. So among 100 vehicles, maybe 50 vehicles should take left, 40 vehicles should go straight, 10 vehicles should go right. You can define that on under the vehicle routes. Vehicle attribute decision is advanced method to provide some kind of scripting values. So if you need to overwrite the simulation values, and if you need to overwrite some of the vehicle parameter values on the fly, you can do that one by doing vehicle attribute decisions. Parking lot is for parking simulation. You can also do parking simulation in VISSIM. So for that one, dedicatedly, we also have parking lots. And rest of the two, public transport stops and public transport lines is dedicated for the public service, public bus or public train or whatever. So on the second part, we'll discuss about the public transport, how we can model the public transport, or for example, we have road network, how we can define a bus route, etc. And we'll discuss that on into the second session. So pretty much that's the content for the first session. And if you don't have any question, we can take a 30 minutes break, and after the break, we'll continue with our we can continue with our public transport part with under our second session. Before taking the break, just in case, I'm checking with you if you have any question. Okay, seems like there's no question, so let's take a break, 30 minutes break, and after the break, we'll continue with our public transport section. All right, I'm back. Just let me know if you are back, and if so, then we can continue our second session. Can you continue our second session? All right. Our second session is dedicatedly explicitly for the public transit. And for that one, I've also shared a folder with you for the public transit example. If you go to the folder, there's a folder named with pt_example1. So just go there. And here we have two examples. One is transit.inpx and another one is transit_final.inpx. Let's open the first one, transit.inpx. All right. So here we have an pre-built network file, and on top of this network file, we will be drawing the public transit line. Okay, so drawing the public transit line, few questions. So what are the basic difference between the private transport versus public transport, or what are the main considerations that we should think of for a public transit? So for example, let me give you a hint. For the private transport, our main consideration is the shortest time, shortest path, or accessibility or mobility, right? So for the public transit, what could be the potential considerations for the public transit? Any idea? Shortest time, shortest path, or anything else? What could be? Here is next thing. First thing is, I mean, what is the purpose of your public transit? That's my question. To reach you or mass public transport, kind of. Anything else? To increase the capacity of the road. So for example, this is a city, for example, and this could be the starting point of a public transit line. And the bus generate or could start from this point and all the way, it can end here. So if it takes the shortest route, it starts from here and it will make a left turn here, and then it can go in that way, right? So together within cheapest cost and shortest time. Affordable and state owned. Any other option you might think of? Okay, so the main purpose for public transit is to have the maximum service area, or to serve the maximum people within a certain zone or within a certain service area, whatever. So to serve the maximum people, that's the main purpose of the public transit. So that's why most of the cases public transit are state owned or subsidized by the government or subsidized by the local state or local city. That's why that is affordable. The main purpose is to the maximum people. So that's why, for example, if this is the starting point and if this is the ending point of a certain bus route, not necessarily the bus will just come here and take the left turn and take again left turn and go there. The main purpose is it will try to cover the maximum area of that city. So it will continue go there, and probably it will have a loop here and then go in that way. So that's the main purpose of public transport. So that's why when we are going to model public transport, two things we need to keep in mind. First one is maximum serviceability of the people, and next thing is definitely those bus should not have the same driving characteristics or vehicle characteristics or even service characteristics as similar as the typical private transport. Meaning, for example, a bus that might be what maybe whatever a public transport from Dhaka. So there may definitely the driving behavior of that bus or the routing choice of that bus should not be the same as the typical driving behavior or route choice of a typical car, right? It has a very oil-defined route. It has a very oil-defined stop. It has a very defined limit of headway it needs to maintain. However, in context to our Dhaka city, the headway is a little bit tricky to maintain for the bus. I know because of the congestion and queuing. However, they're supposed to maintain a very specific headway, right? But because of the congestion and queuing, they cannot. But in ideal condition, they need to maintain very specific route, very specific stop, and very specific headway. Okay, so for those cases, what are the parameters or what are the network object items that we need to specify for the public route? First, definitely we need to define a very defined uh, uh, driving route for the public transport, right? We need to define the route for the public transport. That's the first thing. Second thing is we'll also need to define the very specific stops where the bus should stop and to alert the passengers or to board the passengers. So those are the main two things that we need to define or assign under the public transport route choice or public transport modeling. All right. So let's here under the public transport, that's we have two options. First one is public transport stops, and next one is public transport line. So let's start with stops. So let's assume this is one of the paths for a buses, one of the paths for the buses, and we need to define a stop here, right? So this is a bus bay. So either, I mean, depends on your design. You might have a bus bay so that bus can park there and alight or board the passengers. Or maybe in our cases, in our Dhaka cases, most of the cases bus might stop on the main line, which actually block the road or actually reduce the capacity, right? So ideal condition is always to provide a bus bay. So now the question is how we can provide the bus bay. As we already have the bus bay, for the training purpose, I'm going to delete this one so that I can show you how you can draw the bus bay. All right. So there are several ways you can draw the bus bay. First is you can create a link. You can create a link there. After creating the link, you can create a connector, maybe 5. And if I move it here, you can create another connector from there. Wait from here to there. Okay, in that way, we can define the bus bay, right? So the bus, those who are supposed to take this route, so using this connector, they can go to that specific link number 84, and they can stop there to alight or to board passengers. That's one way you can do the bus bay. Or we also have built-in option. You can directly prepare the bus bay from here. So just right click and first you need to define the public transport stop. So define the public transport stop here. Click OK, and then now right click, add platform age or add lay-by stop. Okay, just click that one. So VISSIM will automatically create a lay-by stop and move that public transport stop to that lay-by stop or bus bay. So again, first create the public transport stop, and now right click on that public transport stop and add lay-by stop. So VISSIM will automatically create that bus bay for you. So for example, there are two public routes or public transport routes, or maybe two bus routes. So, and there might have multiple bus stops, right? This is one bus stops and one of the bus stops, and this is another bus stop. We might have few other bus stops here. This could be a junction, right? It could be farm gate, right? So bus will stop here and probably wait there for a longer time, maybe 10 minutes or 15 minutes or whatever. So, and once they're done, they can go there and they can continue to their work. So first we need to define the bus stops. Okay, so here bus stop, and we have one more bus stop here, etc. Okay, now next thing is the length of the bus stop. So for example, if I measure the length of this bus stop, I can say this bus stop's length is 57 feet, which is sufficient for a bus. Usually a bus length is for around 47 or 48 feet. So typically bus stop, public transport bus stop, 50 feet is fine, sufficient. One thing to make sure your public transport stop is bigger than your bus size. So if your public transport stop is smaller than your bus size, technically bus will come here and will stop there, but some cases you might see some weird behavior. So make sure your bus stop is way bigger or big enough to accommodate an entire bus. Okay, that's one thing. Let's assume we might have multiple routes along this road, right? So instead of a single bus, it might happen multiple buses will come to that stop at the same time. So probably two buses will come into that stop at the same time, right? So in that case, instead of 50 feet, we need to provide the appropriate length for the two buses. So two buses might be 50 feet or maybe 45 plus 45, 90 plus additional headway 5 feet. So probably 95 feet, or probably we can provide 100 feet for that bus length. So in that case, create another bus stop with 100 feet, length 100 feet. All right, now click OK. Now this is 100 feet and add lay-by stop. So now this is sufficient for two buses to be served simultaneously. All right. If that happens for all of the stops, you need to do that one. Make sure you are properly coding all the stops appropriately with your number of served buses. Okay, so first, this is the first thing that you need to make ensure. All right, so when you are done with all of them, put appropriate bus stops, all of them, the next thing is we need to put the public transport line. So this next, we need to select public transport line. And same thing as, oh, already some public transport lines, right? Oh, you see, Dhaka, Chaka, Gaptuli 001. I already prepared some examples. I saved this one here. Okay, so let's delete all of them. All right. So public transport line. So what we can do, maybe this is the starting point and this is the ending point of the bus. And we might have multiple public bus routes, right? As you see here, Dhaka Chaka, Gaptuli, or whatever, multiple public transit route. So just right click here, select the starting point and select the ending point first. All right, so give it a name. Maybe this is Dhaka Chaka. All right. So this is one of the routes. When you draw the route here in the VISSIM, by defining the starting point and by the ending point, VISSIM will automatically complete the route by taking the shortest path. Here you see this is the shortest path for that route. So VISSIM will automatically complete that route for you by taking the shortest path. However, as we discussed earlier, the main purpose of public transport line is not the shortest path. Basically, the main purpose is maximum serviceability or to serve the maximum people, right? So definitely for that specific route, for that specific service, Dhaka Chaka, this could not or might not be the appropriate route. This route might be taking in that way, taking into that circle, and then probably going that way. So after complete the route automatically from the VISSIM, then we need to modify the route. All right, so to modify the route, select the route. Okay, so if that is unselected, you can select this one from here, or you can select this one by selecting the starting point. Either way, you can select the route. All right, when your route is selected, next thing, now you need to add intermediate points. So again, hold Control key and right click. Hold Control key and right click. Now with the intermediate points, if you move the intermediate points, VISSIM will automatically now find the new possible best route. Maybe this is in that way, or maybe we might need to have one more intermediate points to route the bus to enter into that loop, right? So we can add one more intermediate point and move it here. So in that way, you can guide or you can reassign the route appropriately along the bus route path. Okay, now you probably notice the route is going over that link. However, it missed that bus stop, right? As that is a bus route, bus definitely should take that stop. So we'll also need to do a little bit nuances on this location to guide the bus appropriately to that stop. Okay, so there's a good trick here that you can do. So for example, if I just add one intermediate point, for example, here, and if I move it here, as I zoomed in, so there might be a chance VISSIM will automatically automatically shorten the route for your downstream side. So for example, if I move it here, there sometimes VISSIM will automatically truncate that route and probably move it from that line to that from link number from this link to that link. Okay, so just to make ensure not to happen that one, so what you can do, you can add two more pivot points at the upstream and downstream of your stop. So this is our stop, and add one more pivot point at the upstream and one more pivot point at the downstream. Now if you move something from here, that will be guided by these two pivot points. You see, when I move this one, the starting point pivot point is pink color and downstream pivot point is cyan color. So if I move something here, everything will be guided, but will be fixed based on those two, one upstream and one downstream pivot point. All right. Same thing here. We need to get the bus to that specific bus stop. So add one more intermediate point and add two more pivot points at the starting point and at the upstream of that stop and downstream of that stop. Now on to that stop. And do we need any more? Oh, okay. We also need to move this one. So add one more pivot point upstream, downstream, and this is the stop. Now we are done with all the appropriate route, right? So this is the routing starting point. This is the route first stop. This is the second stop. And the bus is taking that loop. And this is the third stop. And after taking that loop, and then it will go away. So probably that is route for Dhaka Chaka, right? Or maybe we might have another bus route. So let's create another bus route. Same thing, select public transport line and hold Control key and right click there. That's the starting point and put the ending point here. and give it a maybe its name could be Express, right? Express bus could be. Okay, and this express bus is probably supposed to take this route instead of taking that loop, instead of waiting there, as this is express bus or could be BRT or whatever. So this will go in that way, and it is taking left from that third intersection, and it will take that route. So again, same thing, add one more intermediate point, move it to here. All right, now it will stop. Probably this express bus will only stop on this second stop, right? It won't stop on the first one. So just add one intermediate point and two pivot points, move this one there. Okay, so this bus will only stop on this second stop, and it skips the first stop. In that way, you can define this. Okay, so adding this stop is simple. Select public transport stop and hold Control key and right click, hold your right click mouse, drag, and just to release your right click. Then it is asking for some name. Then that is the stop, and right click on your stop, add lay-by stop. It will automatically create a bus bay, and it will move the stop to the bus bay. All right. So in that way, now we know how we can create the public transport stop as well as public transport line. Okay, now let's deep dive into a little bit more detailing on those two items, public transport stop and public transport line. So let's go to one of the public transport stop, just double click and open the window for the PT stop. PT stop means public transport stop. First, under the PT stop, we have two tabs. First one is base data. Second one is for the boarding passengers. So base data is just for the basic information. So for example, this PT stop is on link number 84. So if I hover over here, you see that is link number 84. So it is describing that one. It is link number 84, and -1 means lane number. So it has only one lane. So link number 84, lane number 1. Okay. Second one is length, what of the bus stop, and third one is feet. At how much? I mean, 0.67 feet means what is the starting point from the link, from the upstream of that link. So this stop starts at 0.673, the downstream of that link, and downstream of the starting point of that link. Okay. Now, next one is boarding passengers. Here you can define the boarding passengers, volume, time travel, etc. So right click, add. You can add multiple volume or time frame, etc. So if I extend this one, so you can add the volumes here. You can define the time from this time to starting time to ending time. You can define for that time period what are the volumes, passenger volume, and then either that is for all public transit line or very specific public transit line. So we have two public transit lines, right? One is Dhaka Chaka and another one is Express Bus. So if the volume is for a very specific one, you can select the specific one, or if the volume is true for all public transit lines, you can select all public transit lines, whatever. Okay, now let's open the feature menu for the public transport line. So you can, again, you can directly open by double clicking this one, or you can open double clicking from here. Okay, so here After opening this one, it has total three tabs. First one is base data. Again, it says from which link it starts. It starts from link number 5. And this route is valid for what vehicle type? As that is public transport, that is bus, you say bus. If you want to do modeling for the light rail or heavy rail, you can also do that one as well. So for example, Dhaka's new light rail or metro rail, you can also do that one for rail as well. So as this is bus, so you say that is bus. All right. Now, desired speed distributions, you can also define the desired speed distributions for the buses. Next one is time offset. What would be the offset for the bus for the two consecutive service of the bus? And entry time distribution. So for the entry time, what would be the time distribution? Is that very stochastic or that would be very deterministic? You can define that one as well. So you can define that one from here. Okay. Slack time fraction means if a bus runs early or if a bus runs late, so you can adjust the early and lateness by changing the values of this slack time fraction. Okay. So slack time fraction mostly stands for the early. So if a bus runs early into your stop bay, then how many seconds it will wait there just to adjust with its scheduled time. You can define that one from the slack time distribution. Okay, next step is departure times. You can define the departure times from here. So right click, add, or if your departure time is, or if your headway is, if your bus service is maintaining a very constant headway, in that case, what you can do, you can generate the departure time by just click generate start times, and here you can time begin time and end time, and here you can define the rate, maybe begin time 0 second, end time 3600 second, and your rate is probably each bus will stop every 15 minutes, meaning 900 seconds, right? And this is the course, first stop, second stop, and you can also define the occupancy. Probably occupancy is at maybe be 45 passengers per vehicle. Click OK. Now here, it will automatically create the headway. First headway is 0 second, meaning the very start time of your simulation, then 15 minutes, 30 minutes, 45 minutes, and the last 1 hour at the 1 hour mark. And this is the occupancy for each of them. Now, if you think you have some different values, you can edit that one anytime later. Okay. So that means under the Dhaka Chaka route service, they have total 1, 2, 3, 4, 5 buses that will appear into the simulation period. First bus will appear at exactly at 0 seconds. Second bus will appear at 15-minute mark. Third bus will appear at 30 minutes mark, and so forth. Okay. Next one is PT telegrams. This is for doing some kind of evaluation and result analysis. So for example, send PT telegrams. This one is also important when your bus needs to communicate with the signals. So the bus needs to send the signals to the beacon signals to the lamp post or signal lights to turn the red signal into green. In that case, send PT signals, and from here you can do bus transit priority or some other extra things. Okay. All right. So now click OK. You can do the same thing. So for express bus, double click, maybe express bus departure time. Express bus arrives once in every 30 minutes. So right click, generate start time, maybe once in every 30 minutes, 1800 seconds. And occupancy, probably occupancy could be 30. Click OK. So now first bus will arrive at 0 second, second bus will arrive at 30 minutes mark, and last bus will arrive at 60 minutes mark. And their occupancy is 30. Click OK. Okay. Now, For example, this is our express bus, right? Our express from the express bus route choice, we can see that our express bus is taking only one stop at the second stop, right? So, however, this is the stop bus. I mean, for example, if I run the simulation, bus won't automatically generate from this stop. That won't generate from here, right? Bus definitely will generate from the starting point, and it will travel all the way there, and it comes here. Same thing for any of the for the Dhaka Chaka. This is the first stop. Bus will generate here, and it will travel in that distance, and then it will come into that first stop. Okay, so now, for example, for the express bus, as this is the first or only stop for the express bus, and if we look into our departure time, you see first bus will come at 0 seconds, second bus will come at exactly at 30 minutes mark, 60 minutes mark, right? Meaning these numbers or this time is for this very specific stop. Or alternative way, what we can say, if we run the simulation, we are expecting the bus to show up on this stop at 0 seconds mark or 1800 seconds mark or 3600 seconds mark. Right? But if we run the simulation, the bus will generate there at 0 second or 3600 second or 1800 second, generate there first, and then it will travel, and then it will come here. It will dwell here, right? So definitely it needs some time to travel from its origin point to its first stop, as well as the bus will dwell here for some time to alight or to board passengers. So here we have two times. One is travel time from the starting point all the way to its first stop, as well as the dwell time at his first stop. So to cover those times, or to consider those travel time from the starting point all the way to the first stop, as well as its dwell time on its first stop, we have this entry time offset. By default, use entry time offset means 0, meaning we are expecting the bus will generate here exactly at 0 second, and we are also expecting the bus to be here on the first stop exactly at 0 second. But it requires some travel time, right? So that's why we have this entry time offset. So entry time offset is basically travel time from the starting point all the way to the first stop plus dwell time of that bus on that first stop. So let's measure the distance from here to all the way here, which is around 1332 feet, right? Or let's assume 1300 feet. So if the bus is running at maybe 40 kilometer per hour to feet per second, 36.45, 36 seconds, right? So the travel time for the bus from the starting point all the way to stop is 36 seconds. Okay, so that's the travel time. And after traveling here, the bus will definitely dwell here for some time to alight and to board the passengers. So probably it requires extra 30 seconds here, or maybe 60 seconds. So 60 plus 36 seconds is 96 seconds. So our entry time offset for the express bus should be 96 seconds. So make sure when you do public transport modeling, that is one of the common mistakes. Make sure you put the appropriate entry time offset for your corresponding bus route. For the Dhaka Chaka, entry time offset would be definitely probably from this starting point all the way here, maybe 4 or 5 seconds. Let's assume 5 seconds, and maybe dual time 60 seconds. So 5 plus 60 is 65 seconds. All right. Now, We are defining the stop, we are defining the route, we have also defined the entry time offset. Now, if you need to do some additional thing, you can also do that one from here. Under the public transport line, on the top of the list, you see there is a drop-down option. So from here, you can select any of the options, depends on your needs. Let's select the first one, departure time. If you select this one, you see, as we already defined, the first bus will depart at exactly at 0 second, 1800 seconds, 3600 seconds, and each time occupancy is 30. Okay. You can definitely edit, add, delete, you can, do anything from here if you need to. Now, let's check the second line stop. Okay, so from here we can see the express bus will stop at public transport stop. Put the name for that stop is Karwan Bazar. So this bus will stop only on that stop location, Karwan Bazar. For the Dhaka Chaka, the bus will stop at 4 stops. So this is one, and then Karan Bazar, second, and last one is Farmgate. All right. Now, another interesting thing here, if I run the simulation, though if I run the simulation, on the simulation, you can see none of the buses under this Dhaka Chaka would stop any of the stop point, neither this one, nor this one, nor this one. The reason is that for Dhaka Chaka, none of the stop, even though we define the bus route through those stops, but those stops are not active for that specific route. So we need to make sure which stop is active for that specific route. So those are the available stops for that bus. And among those available stop, maybe only stop number 1 and 4 should be active. 2 should be inactive. That means Dhaka Chaka has available stop at Karan Bazar, but that bus Karan Bazar. Okay. Now, under that bus route, you can also check which stops are active for that specific bus route. You can check that one from this line stop table, or you can directly check that one from your network editor. Immediately when you choose a certain stop to be active, you see that stop will turn into red color and with a white arrow mark, meaning that stop is active under that bus route. Stop number, from here we can say stop number 1 and stop number 3 is active. So this one and this one is not active. You see that's why that is a different color. That's a different color. And last one, this one is also active. You see, with arrow mark. So in that case, so for every bus route, you can define where among all the available stops are active for that specific bus routes. Okay. Now, how do you calculate the entry time offset? You remember we discussed about one thing is travel time, and another thing we discussed about the dwell time, how many seconds the bus will stop there. We can also define the dwell time for each of the bus routes on each of the stops as well. Might be Dhaka Chaka might not have the same dwell time at each stops, right? So we probably can expect it has higher dwell time at the Farmgate stop, whereas it has a lower dwell time at some other stops, right? So it might have varying dwell time at different stops. We can define that one as well. So for example, Dhaka Chaka, it stops the first stop point and the dwell time definition. If I move this one a little bit to the left, okay, here is the dwell time definition that is based on calculation or distribution. Okay, so let's start with the distribution first. So dwell time definition is based on distribution. Now, what would be the distribution? To check that distribution, you see that black range. If you select the black range, it will open up a new window, and from here you can select all the available items under that line stop options. So from here, look for the dwell time. So you see dwell time distributions. So move it immediately after the dwell time definition, dwell time distributions. Okay, now from here you can see the bus will stop at the first stop, and it will the dwell time definition is dwell time distribution based on dwell time distribution, and dwell time distribution is based on this one, dwell time distribution. Again, we don't know what does one mean, right? So to check that one, we need to go to the distribution, time distribution, right? This is time. Here we can see real time distribution. So base data, distributions, and from here, time. Okay. So from here, we can see one means with mean value 1.30. Let's give another distribution. So probably this is 60 seconds distribution. Lower limit could be 50 seconds. Upper limit could be 80 seconds, right? Empirical, or we can also put some nominal values with average value 60 seconds, standard deviation 5 seconds. You see, it creates a nice half bell curve. Okay, so this is 60 seconds. And now if we go to our line stop, and from here real time distribution, we can select 60 seconds. For the first stop. Under the distribution, let's create another distribution, maybe 5 minutes. 5 minutes equivalent to 300 seconds, and maybe normal distributions, 300 seconds, and standard deviation could be 20 seconds, right? So another nice half bell curve, 20 seconds. This is 300 seconds, and now here, bus stops at farm gate, and dual time definition should be distribution, and this distribution should be 300 seconds. So that Dhaka Chaka bus will stop at the first stop for 1 minute 60 seconds, and at third stop that will stop for 5 minutes or 300 seconds. In that way, we can define the varying dual time distribution for different stops, and even for different bus lines as well. Any questions or anything that you want me to show you again? Okay, time distributions. So any kind of distribution you can get under base data and distributions, and from here time. So for example, if you would like to add your own custom time distribution, so simply you can click the plus icon and it will open up this window, give it a name, maybe 2 minutes, right? 120 seconds. And your time distribution could be normal distribution. And from here, your average is 120. And your normal distribution could be 15 seconds. And you are done. So this is your time distribution. And now you can define the time distribution here, 120 seconds. Or maybe you can change this one. Sorry. You can change this one to 120 seconds. So in that way, you can change your time distributions from one time distribution to another. So now the bus will stop at the first stop for 2 minutes. Okay. Now there's a question for you. Is there any other potential method can follow to dwell on a certain stop based on very fixed dwell time distribution? So maybe for example, on the bus first stop, the bus is supposed to dwell there for 120 seconds, meaning 2 minutes, right? But the bus will show up there and seems like there's no boarding passengers or very few boarding passengers, very few alighting passengers, maybe one or two boarding passengers, same thing, two or three alighting passengers. And for that case, the bus only need maybe 15 seconds or 20 seconds, right? The bus doesn't require to dwell there for 120 seconds long, right? So what do you think? In that case, what could be the best method for the bus to dwell on a certain area or certain section or a certain stop instead of having that fixed dwell time distribution? What could be the best method or what could be the efficient method? Any idea? Yeah, dwell time can be variable based on the occupancy. Occupancy. Okay, so for example, a bus arrives here and for example, bus's total occupancy at this stop, total occupancy is 25. None of the passengers alight there, or none of the passengers board on that stop. So in that case, does that or should that depend on the occupancy? Exactly. So occupancy is not the determining factor for the dwell time. Another best method or best approach for the dwell time is based on the boarding passengers and based on the alighting passengers. So instead of defining the dwell time based on very specific dwell time distributions, so what we can do, we can change the dwell time definition from distribution to calculation. Immediately, when you change that one to calculation, you see the dual time distribution cell is grayed out, meaning those cells are not valid. Now, you see, we have door close delay time and door lock duration before departure. We have active use this one and calculation. So now this one will be into consideration. And another thing is number of boarding passengers and alighting passengers. So to do that one from here, um, alighting percentage and what is few more boarding possible departure pass skipping alighting compositions real-time distribution network public transport line. I'm looking for another option. Okay, alighting percentage, that one. There's another option for the number of passengers. Public transport lines, public transport stop. Oh, okay. We can get those numbers from here. Departure time here. We have the each stops. No, not from here. I'm looking for that one. Just give me a minute. line stops from here. Okay, so I cannot see that one right here. That could be somewhere in some of the options, or probably somewhere here, alighting locations, somewhere here. I cannot find that one right now. Okay, so when you choose from distribution to calculation method, you can define the number of boarding passengers. You can also define the number of alighting passengers. And based on that, how many seconds would it require for each boarding and alighting? VISSIM will automatically calculate the dwell time, and based on that, the bus will dwell there for that very specific time associated with the calculation of the boarding passengers and alighting passengers. All right. And in addition to that, for the 3D modeling, you can also define the door close delay, how many seconds you want for the door to be closed. And this is the before departure, after how many seconds before the bus depart, how many seconds before that door starts closing, you can find that one from here. All right. So in that way, we can also define that one as well from here. Okay, next option is line sequence. So for example, here, this is express bus. The all the line sequences it follows from the starting point all the way to the end. For example, it starts with um, link number 10,019, meaning that is connector. Then it goes on link number 4, link number 10,066, link number 86. It follows that sequence. This is the link behavior type, urban motorized. This is the display type, level. So it is all the informations in the sequential way from the starting all the way to the ending. Okay. Now, again, if you select the public transport stop and right click, and from here, edit PT line 1, PT stop 4, pass 1. If you click that one, then it will show up its feature window. It says it is active for that specific line stop. This is log before departure time, the same parameter that we saw under the public transport lines. You can also define those parameters here in individually from each of the stops. Right click, select that one first. Right click and edit PT line stop. Okay. So one more thing, sometimes when bus appears on a certain stop, there might be no passengers to be waited there for boarding, or there are no passengers to be alighting. In that case, you can choose that one, skipping possible. So if there is none of if there is no demand for the passengers, then that bus will skip that certain stop. So you can do as well. Okay, so now if I open the stop list, so this is the stop list. You can open the stop list from here, right click and show list. And from here, it shows all total 4 stops, bus stop, Karan Bazar, Farmgate, and you can give some other names if you have. And so for example, first one, volume. It shows the boarding volume here on the right. You can define the boarding volume from each of the time period. So if you have multiple time periods from your splitting time, maybe 0 to 1500 seconds, or then 1500 seconds to 3000 seconds, you can define that one from here. You can define the volume, and you can define the volume and whether that is active for all PT lines or very specific PT lines, etc. Maybe not all PT lines, only for maybe only for express bus or whatever. Okay, and from this drop-down option, there are public transport line stop, public transport lines active. So public transport line stop, it shows all the stops, available stops for that bus, for that route. You see, and from here, another option is public transport active, only shows the active routes for that bus. So active route, active stop bus routes. Okay. So either way, you can interact with between the public transport stuff and public transport lines. Either from public transport line, this is the public transport line. From here, you can go to the stops. For example, here we can see the stops. Or from the stops, this is the stops. From the stops, you can go to the public transport lines as well. So it has both interactive feature from one parameter to another parameter versus another parameter to your previous parameter. All right, any questions regarding the public transport? Okay, seems like there's no question. Let's move to the another example file. I have also shared another example file, Park and Ride with Pedestrians, which is a complete example. And here, this is a very good example showing all the possible interactions, possible traffic interactions into VISSIM. So, for example, when we go to a road, what kind of available things or what kind of traffic items or what kind of traffic pattern that we can see? Definitely, when you go to the road, we can see lots of traffic, meaning lots of vehicles, right? It could be bus, truck, or for Bangladesh, rickshaw, or some other things. Definitely, we can see pedestrians, passengers, right? Apart from that, definitely some public transport route, public transport buses, public transport vehicles as well, right? So public transport could be a bus, public transport could be a light rail, or public transport could be a heavy rail, whatever, right? In addition to that, we can also see crosswalk. We can also see a parking spot. So this is a good example of pseudo example, park and drop off option. So this example name is Park and Ride with Pedestrian. So this is a very good complete example or interactive example between the private transport, public transport, pedestrian, passengers, parking, everything. So if you open this one and simply just run the simulation by clicking the simulation continuous, then you will see simulation is running. You see a car shows up here, and then it drops passengers here. And then another car shows up here, and those passengers is taking that route. They'll cross that link. And this car is waiting for the pedestrians. And now they wait here for the light rail. And light rail shows up at its defined schedules. They board in, and after a certain dwell time, that light rail departs. And few other passengers show up there and waiting here for the next train to arrive. And once that train will arrive there, and then they will go there. And here is another train for the westbound traffic, and some passengers alight from the train, and they can take the taxi service or Uber, and they just board into that car, and now this car is ready for depart. Here is still some passengers is waiting for the next train. You see that car is now departing with the passengers. So this is one of the very good examples for the VISSIM, what you can do. I mean, the best part of VISSIM is you can incorporate everything in under your single modeling file. You have normal vehicle simulation, pedestrian simulation, light rail simulation, public transport, parking. You have everything under your same umbrella. So here, the modeling. So for example, if I stop this one, the modeling is not pretty much straightforward. This one, it has lots of scripting. You see, those are the attribute modifications. You need to do some kind of attribute modifications. You need to define some coding here. If I open this one entirely, so for example, this is the coding, the values, and you need to define some filtering method. So you can apply the Python scripting here to do some kind of advanced coding, advanced scripting in that way. So for example, here we have total 4 attribute modifications, and we also have vehicle, defined vehicle type. One is for car and another one is for tram, meaning the light rail. And with this attribute modification, pedestrians vehicle will show up here and they will wait here for the parking lot. Those are parking lot. If I turn this on, if I go to the 2D mode, you see then that blue color, those are the parking lot. And if I go to the 3D, so from here, what else? Oh, this pedestrian crossing area. So if I go to the 2D mode and if I go to the conflict area, if I turn this on, okay, here you see there's some conflict areas here between the pedestrian link versus the main link for the traffic, right? And definitely when a pedestrian will appear here, pedestrian has the highest priority over the traffic, right? So if pedestrian show up here, pedestrian should have the highest priority to cross the road. So that's why you see along along the pedestrian route, we have green color, meaning it has highest priority or it has higher right of way compared to the vehicle. So vehicle along the vehicle route, you see that is red, meaning vehicle, if a vehicle show up here and if a vehicle sees there is a pedestrian crossing the road, vehicle will definitely yield the pedestrian. So those yielding behavior you can define by these conflict areas as well. All right, so now, for example, in the 3D mode, okay, or even on the 2D mode, if you run the simulation and if you don't want to show those conflict area, because you have defined the conflict area, you are fine with the conflict area rules. Now you need to show that one, you can just turn that off. Okay, so conflict area is gone, meaning not gone, conflict area is hidden. That's still inactive in operation, but that's hidden. So now you have a nice view from here. So in that way, you can do a complete modeling into VISSIM, starting from your scratch from your link and then building the network for your regular traffic, private traffic, then defining your public transport for your bus route. You can also define the pedestrian by doing VSWAP modeling. You see pedestrian show up here, they walk nicely and cross the road and they are waiting here for the light rail and they're taking the train. So in that way, you can define or you can build your own network for your own city or for your own jurisdictions. So you are the future traffic modelers, future traffic leaders, and in future, definitely you will be doing this one to have a nice model for your own city or for your own country, whatever. So pretty much that's it for our today's session. Still, I have lots of things to say because if you can say me, I can continue maybe for not 4 hours, 3 hours by just saying lots of ins and outs of the VISSIM, what we can do, what are the methods, etc. But because of the time constraint, so I try to cover the overall idea, what you can do from the scratch, and what are the options under the public transport. So yeah, so we still have 9 minutes. Rest of the 9 minutes, it's for you. If you have any question or anything, so rest of the time is for you.
Thank you, Shakhawat Bhai, for such a comprehensive and insightful session. We are very grateful for the detailed explanation of VSIM's operation and most especially for your generosity in providing the training license for the software, which is, of course, immensely valuable for all the participants. So before we conclude today's session, may I ask if anyone from the audience has any final questions for Bhai? You may type in the chat box or you may unmute yourself and ask. Either is fine. Uh, yes, I see someone raising their
Yeah, there's
hand.
a question. Anyone tried putting network data from Dhaka? What do you mean by network data? Or done similar research in the South Asian context? What do you mean by network data? Yeah, John, you can unmute yourself and speak up.
Good day. Am I audible?
Yeah.
First of all, thank you for this very insightful talk. We are from the Philippines and we are currently uh, on our thesis, undergraduate thesis, that will focus on the road network of our university. But our main problem is the student version or the demo version don't have the full um, sp- uh, what do you call that?
Yeah,
They
full
don't have
capabilities. I
all
know. Yep.
the things that we can use in our thesis. So we are planning to have the pro or if there is another choice so that we can have the full version of the software and then we can proceed to our thesis. Um is there anything that we can do to have the version or just we really need to buy the pro version? Thank you so
Okay, yeah.
much.
First of all, thank you for your question and thank you for joining into our today's organized from Bangladesh and you are joining from Philippines. First of all, thank you for joining into this session. Now, regarding to your question, yes, for the students and for academics, we also have a different version for the VISSIM. So for academics, we have VISSIM academic license. So probably your professor or your department can purchase that VISSIM academic license, and we also have another VISSIM research license. So either one should be good for your undergrad thesis, either academic license or research license. So probably your department or your professor could coordinate or could contact us, and we can provide you the academic license or research license.
Can we have a follow-up question?
Sure.
If ever we are going to purchase the pro version of the software, how much would it cost and how long we can use it before it
Okay.
expires?
So first thing is our pricing is different based on the region. So for example, as I'm conducting the training from the North America, so only for the North America, I have we have dedicated team. For the Middle East, we have dedicated team. For Asia, we have dedicated team. And obviously our pricing is different from region to region because the pricing that we are offering here might or could not be um, affordable for the South Asian countries. So our pricing is different. I'm not sure. Probably Philippine is Probably you can contact with the Dubai office or Singapore office. They're covering that area, or maybe China. I'm not sure. So I need to check which office is conducting in that region. So first, pricing is different based on the regions, and you need to contact our local office based on your regions. Okay. Second thing is we are offering the license for 1 year, or we are also offering perpetual license. So you can purchase the license for, I mean, for up to your life. So we also have subscription option. So once you purchase the license, and you need to subscribe, or you need to renew your subscription each year just to get the updated new features, updated new VSIM. Okay.
Thank you very much.
Okay. There are a few questions. Anyone putting the network from Dhaka done similar research, like replicating road network from Dhaka city and implementing traffic engineering on them? Yeah, I know there are lots of research out there. Lots of modelers are working with VSIM to create the roadway network for certain intersections, but not definitely for entire Dhaka city. For entire Dhaka city, if you are need to do that, won't be the simulation. That would be modeling, mostly travel demand modeling (TDM). I'm not sure if anyone are familiar with the TDM modeling. So travel demand modeling and simulation, those two are different things. Travel demand modeling is for a region, for a city, for a MPO, for a maybe zone, for a division, etc. Okay, so that is travel demand modeling. And simulation is very specific, very detailed, based on your intersection and based on your certain corridor, certain arterial. So simulation is very specific to a certain section, certain corridor, not for the entire region. Okay. But yeah, I know there are lots of firms are working, and right now simulation is becoming popular in Bangladesh to analyze, to see the roadway performance, etc. As Dhaka traffic is non-lane following with heavy influence of paratransit and non-motorized vehicle, how reliable to model and accept realistic results in context of Dhaka traffic? That's a good question. First thing is how reliable we are when we drive into the Dhaka city. Okay. Even though as our drivers in the Dhaka city are not reliable, you don't know the next move of your leading vehicle's driver, which lane they are going to use. Then how do you want to replicate that one into the model, right? So the first one is we first we people need to follow the rules. We first, we people first need to maintain the appropriate guidelines, and then next thing is for the software. But first we need to follow the rules, as we don't have any lane and we are not following the appropriate guidelines. So that's why we have long queuing, congestion, right? Our travel time reliability is pretty high, because we from point A to point B, we don't know how many minutes we might need. Maybe 30 minutes, or sometimes that may be 2 hours. If you apply for thesis license, would there be any discount? Yeah, for the thesis license, we are offering free thesis license. Not discount, you can get the thesis license for free, but for that one, you need to define. Let me share with you the link. You need to describe what you are doing with the thesis, or your purpose, research questions, and then we can assign you the thesis license. Let me give you the link for the thesis license. Okay, so I'm putting that one here in the chat. So anyone, if needs the thesis license, from this link, you can go to the link, and from there, you need to fill out this form. What is your name? What is your university name, university email address, name of the professor, what is your thesis title, estimated date of your thesis submission, and abstract. And then after the submission, then after reviewing your information, if that seems valid, then we can provide you the thesis license for free. All right. So heterogeneous traffic system like our is not simulable. Um, so the main purpose of simulation is to see how behave if that maintains the certain conditions. So certain conditions means if they're following the appropriate guidelines of lane, even um, lane change. So for example, let me show you one of the advanced things from here. Base data, driving behavior, and from here. Okay, here you see car. We have following model, car following model. We also have lane change model. For the lane change, what would be the maximum deceleration, accepted deceleration for yourself, for your own vehicle, or for the trailing vehicle, or when you have free lane change, you have all of the things. Given condition is definitely you need to follow the rules. So if there is no order of the rules, or if there's heterogeneous traffic system, then definitely you cannot replicate that one here in the model. Would you suggest some other similar software to learn traffic that are not as costly as simulation as VISSIM? There's another software which is transmodular, which is a little bit less expensive compared to VISSIM, and there is some free software. I believe Sumo is, yeah, I mentioned, I remember someone mentioned Sumo. So Sumo is a free software. You can play or start learning simulation with Sumo. But again, as that is free, so that is very much limited. You might not have that much option. I've used, oh yeah, someone said I've used Sumo before. It is free and mostly similar. Yep. Thank you so much. The talk is very helpful. Yeah, you are welcome. Thank you for the time, Vaya. Would love to connect with you. Also plan to take advanced lessons on this. Depends. Depends how do you find this useful, or how are you interested. Regarding that one, you need to contact with the BUET ITE first. There's a hand raised from Tofikur Rashid. Do you have any question, Tofikur Rashid?
Yes, am I audible?
Yeah.
Oh, first of all, thank you for your nice support for 4 long hours. First of all, I have a question that the last simulation you have showed us, the park and ride, is it shared with us?
Yeah, if you follow the link, it is shared there.
Oh, I couldn't find. That's why I asked.
If you open the link now, you can find this one there.
I have also downloaded the previous day it was provided us, but I couldn't find. Maybe
I mean, if you download now, then you can find it. I shared this today.
Today.
Yeah. So if you go to if you follow the link and if you download now, then you will find this one there.
Oh, I have downloaded it, so I have missed.
Yeah. So I shared it later.
Oh,
I shared it just probably 30 minutes before the training session. So if you go to the link and if you download it, then you can find it there.
Oh, okay. Thank you. My another question is, nowadays I am working on an intersection. This is a 4-lane intersection. In this intersection, I want to implement the findings from gravity model. The gravity, can I use PTB VISSIM to show the findings of gravity model?
First of all, what is the purpose of applying the gravity model on the intersection?
I want to show the interaction between the land use and transportation. This is the novelty of my research.
So that is not part of the VISSIM. Again, that is part of the TDM, travel demand modeling. So for that one, you need to use PTV VISUM, not VISSIM.
Oh.
So that is part of modeling, not the intersection-based analysis. So this simulation-based analysis, this is very scaled down or very detailed analysis for a certain intersection, for a certain road, etc. But when you are working with for example, traffic versus land use, or as I discussed earlier, when you're working with city level analysis or region level analysis, those are the things that you need to do with the travel demand modeling, TDM. Are you
Oh,
familiar with, for example, four-stage modeling?
four-stage modeling, I'm quite familiar, not too
Yeah,
much.
so you need to do that one with the four-stage modeling, travel demand modeling.
Oh. In that case, if I can do in PTB VISSIM, can I show the trip generations and attractions which I can find from the audiometrics? Can I show it? In PTB,
So
I have saw pedestrian audiometrics, but I couldn't find vehicle audiometrics or something like that. That would be my knowledge gap, I guess.
Okay, so again, there is so for example, if you would like to do the generation, so that you can do with the PTV Vistro. So for very specific purpose, we have very specific software. With PTV Vistro, you can easily do the trip generation.
Oh, I see. That was all from me. Thank you.
Okay. Would you like to have a session on travel demand modeling? Any plan from ITE BUET? Okay, first thing, you need to coordinate with BUET ITE, and from my side, that depends on my time availability, etc. So, for example, as today is 31st night and tomorrow is first day of the year, and I have day off. So, yeah, I have time to. I have time and opportunity to take this class. So, yeah, so stay tuned with ITE BUET, and they will let you know what they have in their mystery box.
Thank you once again so much for this session, Bhai. I think there are no more questions. So with that, I would also like to sincerely thank all the attendees for joining us today, especially those who connected from beyond Bangladesh. So this makes the session truly a global one. With that, we conclude today's session, wishing everyone a very happy and prosperous new year. Thank you, and everyone, please have a wonderful day. Thank you.